Всем привет! Это подкаст .NET и не только, специальный выпуск, в котором мы подготовили материалы с московского DotNext 2019 года. Да, вы можете сказать, что это уже было 2 раза, но самую сладость мы оставили на потом, на финалочку, потому что представляем вам интервью, подборку интервью с звездными спикерами, самыми звездными спикерами прошедшего DotNext. Рафаэль Риалди, Джон Galloway, Christophe Nasarre, Pavel Yosifovich, Wlaschin. Все эти люди представляли одни из самых топовых докладов. Ну, некоторые были, конечно, не самыми топовыми, но это ладно. Но главное, что это очень-очень важные фигуры в .NET-сообществе, у которых всегда есть что сказать. Сразу хочу предупредить, что данные интервью на английском. И если среди вас, уважаемые слушатели, есть кто-то, кто готов помочь подкасту и сообществу с сурдопереводом, пожалуйста, не стесняйтесь писать куда угодно, где угодно. Хоть мне, Сашу Кукушеву, ВКонтакте. Я вам предоставлю всем исходные материалы, и вместе мы сделаем выпуск лучше. Ну, не буду откладывать в долгий ящик. Наслаждайтесь. Hello, my listeners, our listeners. Here's Raffaele Rialdi. Sorry.
It's fine.
Yeah. And today we are going to have a small talk or big talk. It doesn't matter. I don't know how much time do you have.
It will be in room 1, so it will be a huge talk.
Yeah.
At least the room is very large.
No, our podcast is kind of informal. We can discuss everything. So you mentioned your speech about new C# and new .NET, and what do you think about default interface methods? Because
default interface methods is one of my favorite topics because there are
like it too.
discussions about it. I see many developers that are totally scared because they are seeing bodies that are coming inside the interfaces. So let's explain a little bit what is this new features in C#8. The features deals with adding the bodies to both the methods and the properties. But of course, there is not just that there is a field, because the interfaces cannot have a state.
Yes.
This is super important. So we have to double underline this point. Then we will also have access identifiers like public, private, protected, and so on. So we can also add these modifiers that in the past could be used only in classes and structs in interfaces and members. Then there are at least 3 important reasons to add the force interface implementation. The first one is the easiest and the most advertised, is versioning.
Yes.
So, what if you are in BCL team in Microsoft and you are asked to add a new method inside iList, for example, iList of T.
Yes.
It's extremely difficult. I mean, you risk to break the code all over the world for millions of applications, millions of developers that will try to find you and beat you hard because you broke the most important interface that they used before. So, of course, this is not possible. And there are many interfaces that cannot be. Let's think for a moment to the add range method that is available in list of T and is not available in iList of T.
And also,
every time when I start a new project, my hands go automatically in writing an extension method in order to add the add range for iList of T, or at least I collection of T. And so I have the add range available on my project. So basically the idea is what if we can add a new method, but in order not to break the implementation, we want also to provide a default implementation. And this is very handy because if the class implementer in the next version will want to leverage a new improved implementation instead of relying on the default one, he can do it. And so he can override the default implementation and go on and implement a brand new version of the add range body.
Actually, we had a discussion about this topic in the previous releasing of podcast, and my opponent said a phrase like, "Okay, but you are not a BCL developer. Why should you be so interested in this feature?" And I thought about this words.
I have other two important points for that.
Yeah. Yes.
So this is just the beginning. The versioning is important, but in my opinion, it's not the most important. So it's super important in many cases. If you have a large framework and you want to provide versioning, so that's the story, and we will skip this one for a moment. The second is very short, and is of course compatibility with other languages, so interoperability.
Yeah.
So Java and Swift already has this ability, and when you are a language designer, you don't have to think that they are copying between the features about the other languages. It's not a matter of copying, it's just a matter of kind of wave that is driving all language designers, so that you can really match the feature between the languages, because in our modern development world, the applications are more hybrid than we think. And so when you want to mix and match some pieces from one language and another language, it happens that you have to rewrite a certain part of your library in different languages. And if you don't have available as specific features, you will have a hard time in offering this library in different platforms.
Got it. So, in other words, if you want to use a library that has been, automatic transpiled from Java to C#, actually we have a lot of libraries like this.
Exactly. Or if you are an IoT device vendor, and you want to provide library for the .NET world, but also for Android, and then you want to have an iOS version, and you have a really hard time in managing how to develop a library using the least common features that are available across the three languages, because more or less you will develop either in Java or Kotlin for Android, or of course C# for .NET, and iOS with the language of choice, but Swift currently is going great, so that's it. But my preferred reason for default interface members is definitely trades programming. Trades programming, I fallen in love with C++ a long time ago, so I still love C++. I am a co-founder of a community of C++ in Italy. And trades programming is extremely important because it allows you to compose the behavior of your objects. And since the modern languages does not offer anymore the multiple inheritance for very good reasons. I mean, the diamond of death is just one of the reasons, but it leads to confusion for many aspects. Of course, there is the need to find an alternative way to compose the behavior of your object. And so, let's say that you want to isolate a number of methods in a separate entity, let's say, so this generic term entity, and then you identify other sets of methods or properties in another entity and another one, so you end up in having 3 or 4 that can be used like Lego blocks.
Yes.
And whatever you want in your final object, you can choose to aggregate, just to compose the behavior of your object, just reusing this these unities, and you can compose objects, and your design becomes more simpler, and then it's everything is much better. I have a good example tomorrow in my session, and I will show how to use traits programming.
Actually, in game dev, there is a very popular pattern, ECS, anti-component system, and it seems that the article is the same when you specify a logic and business logic to one piece of game logic and composite all different entities, different components and system to one entity.
Yeah,
and
that's absolutely super important. We have to say that it's not a feature that is just finalized in C#8. I participated a lot in a thread that you can find on GitHub about this feature, because I was wondering how to use the base implementation from an object that is going to override it. So you override the base implementation that is available in the interface, and you expect to call like base dot like you do in normal classes, and this won't work. Simply they will go in a Stack Overflow, because since the base implementation is inside an interface, it's a vtable, but the pointer of the vtable has been overridden by the class, and so you end up in an infinite loop. So this requires a change to the CLR, and probably, I'm still not sure about this on the implementation detail, even adding a new IL instruction. So it requires anyway some runtime change. This means that the ability to call the base implementation has been postponed and approved already for C#9. So this is something that will improve over the next versions in C#, and I also hope they will add a few more features to make traits programming even better.
What do you think? If we have such problems, why and such a lot of discussions around default interface method, why don't C# developers create trait instead of add new keyword trait and implement it and get rid of making changes to interfaces?
I can guess, pardon me, I can guess it depends on the difficulty in the implementation, because once you want to aggregate different behaviors from different methods, you end up in needing something that resembles an interface in order not to have the multiple inheritance. So from an implementation perspective, it doesn't make such a big difference. After all, if you don't want to use the default interface members, you are free not to do it. If you don't like it, just don't use it. Otherwise, it's just having an implementation available if you want to leverage it. It's not just something that is mandatory. Of course, if you see this implementation just a way to provide the behavior of your future object, it's, in my opinion, the wrong way to think about it from an architectural perspective. This is the kind of opportunity that you have in your application in order to escape from versioning problems, to interoperate with others, and to have this composition that is difficult in languages like .NET as well as in Java and so on. So if you don't have multiple inheritance, of course it's more difficult. In C++ it's easier also because they have templates that are totally different than generics. Templates are resolved at compile time, and so give you the ability to kind of transform the sources and to make some magics thanks to the compiler. That's very different.
And there are a lot of discussions about templates. There are a lot of guys who don't like templates and can't understand templates properly. I know some guys that said, come on, if you don't understand templates, you're stupid.
Well, that's partly, I agree because the standard template library is the official library for C++. If you don't use STL, you are not using C++ at all, because it's a kind of complementary piece of the language. You cannot use C++ without a standard string, otherwise you are not compatible with anything. Yes, you can implement your kind of string, but how many strings exist in C++? Oh my god, another one? We want the standard one. And this is why the standard template library was invented, in order to satisfy all the requirements and to be as compact as possible. Templates are the best answer available, as far as I know.
Yeah. And actually, when we're talking about C++, there are a lot of complaints about complexity of C++. I mean that, okay, the last version of C++ is overcomplicated and it's hard to learn C++ for students, and it's hard to know it properly, and and I have a question about C#. C# 8 contains lots of features. And what do you think? Can we expect the same fate of C# that I don't know, students or just young developers, instead of learning C#, I don't know, will start learning Go or something like that?
Oh yeah, but this is an interesting topic, because if you watch at the language overview, you will notice that as soon as a language becomes a bit old, in the sense that they have many versions in his evolution, the younger generation stop loving it just because it's complex.
Yes.
It's in my opinion, it's kind of laziness, because in the old times, during the 90s, if you talked in a conference about C++, nobody complained. And there were already available other languages, and that's pure fun. I mean, you will see that the average age in a .NET conference is raising up, and there is not enough younger generation coming, and you may wonder why. In my opinion, the problem is the language and the complexity that is going up. And the younger generation try to escape. It happened with JavaScript, for example. And so you have seen a lot of young men going to JavaScript, and they now begin escaping again, because also JavaScript is becoming more and more complex. And everybody goes to Go, no? Or everybody goes to Rust, just because it's new and they want a fresh thing. But I mean, this happens in every aspect of the human life. It's nothing new. In reality, I have to say, with .NET Core 3, it's not just a revamping of the .NET code base. It's something really totally new. It's compatible, yes. You can easily bring your application to .NET Core, yes. But it's very strong, and the code base has been totally rejuvenated and elaborated in order to be more performant. ASP.NET Core has been totally rewritten. So there are many new things that instead must be evaluated very, very carefully. And on the C++ side, they are paying a very high cost of 2 points. No binary contract. Mm-hmm. There is no binary standard. So you wanted to interoperate with the C++ compiled object. There is no standard way to do it. There are hacks, but no official way. So in the past, Microsoft invented COM for this.
As they're trying to forget it.
Yes, on Unix, there is Corba, and that is totally forgotten. COM is still alive.
Well, I don't want to totally. I would say only in the Java 9 Corba has been excluded finally.
Okay, but I mean, it's part of the past. COM is kind of rejuvenated because, WinRT, the modern application in Windows, blah, 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 all the APIs, if you don't like the UWP stuff, okay? are based on WinRT, and WinRT core is COM. With a different type system, it's easier. Okay, you have the free-threaded marshaller, so it's easier even the threading model. But basically, it's the same unknown good interface, release, and so on. So this is the main problem with the missing ABI from the C++ world. And also, this is good. The other point is the lack of safety. Mm-hmm. And this is scary. Why? Because companies now have a very fast developing cycle. So when you want to go in production very, very fast, your amount of tests must occur in a very short time, and you want to have strong guarantees that the code that is going in production is safe.
It's a good point, because when we're talking about non-functional requirements, I would say security there is only one quality attribute that can be considered as a must for everything. It's a security,
But you are scared that someone may have put some row pointer that pointed to a not allocated memory, and you will screw up.
Yeah.
While in newer languages like Rust, this cannot happen because it is enforced by the compiler. And so Rust is a language that is growing very fastly just because it's giving more safety to the programming model. And this is super important. So I believe Rust will have a bright future from this perspective. C++ is very good still for many topics, but you have to be a smart developer using modern C++, because if you use the C++ just as it was the old C with some new cool features, of course that's very bad. And the C language is probably the language that will have to pay most of the costs, because Rust can be compared at level of performance very closely to the C language, and can be used in kernel mode too.
So, if I understand correctly, when we are talking about C#, we have the same situation.
Yeah, C#, in my opinion, scares a part of the younger generation. They should not be scared, because it's a very nice language, but I want to be objective. I mean, when I talk with people, C#, but there are many things to study, and I mean, it's laziness. This is the main point. But when they discover the language, they discover that it's a very good world, because the ecosystem is very rich, and .NET Core brought inside a lot of new stuff that is extremely interesting, diagnostic, and for example, I will show tomorrow, I can spoil something.
Yeah.
A Windows Form application, which is part of the past, okay, migrated to the new .NET Core 3 using DI. So dependency injection inside, use it with the forms, and you cannot imagine how clean is the code that in the past was totally crappy in order to have references to this form on the one side or on the other, and with the DI you clean up your code base.
Actually, there is an awesome book, Dependency Injection in .NET. It's kind of old book. It's kind of 10 years old or more, and this book is has a chapter that focused on applying DI approach to different .NET application, and that was before .NET Core, and they showed how to do it for console applications, easy, how to do it for ASP MVC application, it's easy too, and with .pf, WinForms, .cf, and there are a lot of hacks that are presented in this book. So yeah, it's
But the game changer was ASP.NET Core, who brought a cool new, very nice ecosystem of tools based on the DI, and now it's incredible to see in a Windows Form application declaring a constructor that can receive from the DI the logger, the configuration, and so on. So if you have a configuration that is specific to your form, you can simply ask to the DI in your constructor to receive the configuration, and you will have. It's very handy. I mean, it's something that in the past was a crappy code, and with the configuration manager going to the app config, but if you want to separate a file, it was kind of mess. And now we have everything inside JSON, which is the de facto standard for this stuff. You have the opportunity also to redirect to other storage if you want. I mean, it's an infinite world of possibilities. And when I explain this to younger people, say, hey, this is super cool. If I go to Node.js, for example, I have 1,000 packages that do pretty much the same. It's also just difficult to pick the correct one. And versioning is a nightmare. The package versioning is a nightmare.
Yeah, I would say from my experience, I don't have a huge experience working with Node.js, but as a regular .NET developer, I use JavaScript frontend.
I had the occasion to go very, very deep dive in Node.js because for my own study purposes, I wrote a C++ plugin in Node.js that emulated, as it was a proxy, any kind of object. And I used this kind of hook in order to redirect the request from JavaScript to a CLR. So I hosted the core CLR inside the C++, and every time JavaScript made a call invoking the new of an object that existed in a class library in C#, I take this from C++ and I ask to the core CLR, please create this object in the manager world. And then I obtained the totally marshalling between the managed class and the JavaScript. At the very end, I was able to create an Electron application with the view model written in C#.
Wow.
And it supports even the promise pattern with asynchronous calls. So the async await with the task of T in C# are fully supported even from JavaScript. And then it's mind-blowing. And it was part of, I showed this stuff of my work in a session a few years ago in CodeFest in Novosibirsk.
Actually, it sounds like a good competitors to .pf or .cm because...
Probably it's a good competitor with Blazor.
Yeah.
But Microsoft knows it because I showed them the demo of my work.
Actually, you mentioned that .NET, ASP.NET Core is well designed, yes.
Yes.
And it seems that the initial, approach of .NET is focusing only to Windows and eventually can be considered as a good opportunity of totally rewriting a whole framework. Because if we take a look to Java, we can see that Java developers of JVM, developers of J2C has to give backend compatibility with all old stuff that used 20 years ago, like Corba.
Yeah.
And but what do you think? What should we expect in 5 years? Because, for example, in .NET Core 3, ASP.NET Core becomes a framework reference, not just a NuGet reference. And as a result, if you want to create a very tiny web application, you can do it. You have to reference all ASP.NET Core framework. It's still lightweight, but anyway, in .NET Core 3, you have to. We can't reference just a part of framework. For example, we can't get rid of Eraser.
Well, it's a kind of pay-per use. So if you now there are these application packages that include all the stuff required for ASP.NET Core to run. But for example, if you look at the worker service template, it's a console application that uses the ASP.NET Core infrastructure to have DI, to have the logging, the configuration stuff, and so on. So basically, yes, if you want to get rid of certain things, you can. And you can also easily create your own template, because you can, using just the command line, say, hey, this application that I just created and configured manually is my new template. And every time you make .NET new, you can refer to your own template and create a new application based on your template. So, I mean, it's very plastic. I mean, you can do whatever you want in this sense. If you want to get rid of certain assembly in ASP.NET Core, you can. Of course, Microsoft decided to put together a few things in order to make your life easier when you decide to write an ASP.NET Core application, which is very common, very popular.
Yeah, and if we take a look at our near future, for example, 5 years, what do you think? Can we expect that ASP.NET Core in 2K25 will become so big, so monstrous, so we will see, okay, it used to be lightweight, but now we want to have a new shiny lightweight web framework.
I get your point, but I don't think so, because now we have packages.
Mm-hmm.
I mean, .NET is probably one of the last platforms to go to packages. It's not it's not an innovation in absolute terms, but nowadays the NuGet platform is very stable. It was not in the past. We have to be sincere. I mean, we have to say the truth. But nowadays the NuGet platform is very solid. And GitHub, for example, offers also the ability for you to publish your own packages, can be a NuGet server. Mm-hmm. And so this is very interesting, because you can rapidly go from the CI/CD perspective and publish the new packages. So I don't expect the main library will become a monster, or at least there will be more and more libraries available, as a good ecosystem pretends to have. Probably many official libraries, that's unspeakable, because we want an official support for the most important thing that happens on the market. But it's a kind of opt-in. If you don't want it, you simply don't preferences and you don't pay for it. Also, with one of the features that I will talk tomorrow as a publish trimming, you will also be able to obtain a single exe, trimming away, so cutting away all the code, and even only a portion of an assembly, not the entire assemblies, trimming away all the IL code that your application is not yet actively using. This means that you can have an exe that is very small. I mean, how much is small is, we can discuss this stuff. But at least you will not bring with you code that is not useful for your application.
Yeah, I understand. It's like the same thing that we have in Xamarin.
Exactly, because the feature comes from Mono, so yeah.
Actually, let's get back to .NET. I just want to ask for a small question. A few years ago, 1 year ago, on DotNext, we discussed the idea of creating a C# standard that's driven by community. The idea that at this moment, C# has a lot of ways to do the same thing. I mean, for example, if you want to make a map, you can use LinkU, you can you can use loops, and so on. And for young developers, it's not exactly good because young developers likes Python because there is only one way to do something in Python.
Yes, it's laziness again.
Yeah,
a bit.
Lazy.
I am very determined on this.
Yeah.
Often it's just a problem of laziness, not evaluating the possibility that you have as an overall. And nowadays, with .NET Core 3, Microsoft did a great move. And they just released the 101, so the 101 videos on all the basics that are related to .NET Core 3. So they are really tutorial and instructing you how to start, where to start for each of the topics that can be covered from with .NET Core. But it's a good starting point. I mean, newer generation have a lot of material to look at and to start from. Probably older generation like me, the approach is different because when we started, we didn't have the internet.
Yeah,
you had to resolve the problem by yourself. I had many problems in programming things, and for many times I encountered the problems that didn't have a published solution. But that's the most important thing. I mean, if you are the first to figure out how to solve a problem, it means that you are not one of the on the average. I mean, it's important. I mean, you have to find a way by yourself. Why not? We are developer. We are solution solver. Not. I mean, that's our job.
Yeah. Actually, in the opposite of person who face issues that that doesn't have reference in internet, that doesn't have reference to the internet, the majority of issues can be Googled by Stack Overflow. But as a result, we have a lot of Stack Overflow developers.
Oh yeah, but often the answer that you can read there are totally wrong, even if there is the most voted. I mean, you have to evaluate carefully the code that you are cutting and pasting in your application, because it happened to me to see the answers, and I was astonished at how bad the answer was and how high grades they received.
Oh, yeah.
I mean, you have to be a mature developer to understand the value of the answer. It's not something that anyone can do, and just copying and pasting from Stack Overflow, you will really grow up and monster up.
Yeah.
Really, really bad.
And I just have a small question, not a small question with big opportunities that in the previous release of our podcast, we had a holy war around architects. That's because, to be honest, the majority of developers doesn't understand who is architect. According to your description, you're architect. So please, could you share your meaning? What do you think? Who is an architect in software, and how to be an architect? If someone of our listeners wants to be an architect.
But apart from the basic knowledge that you should have to understand like patterns and standard way of approaching the usual design problems, of course, that I give that for granted, of course. But I really don't see any way for a guy to be an architect without knowing how to code.
Yeah.
That's important, because too often I enter in a meeting and I find people claiming themselves architects, and they have no clue of what means implementing what they are drawing on the dashboard, and that's very, very bad. And this doesn't happen, for example, in Microsoft. When we go there for meetings, and I see many important architects, well known, that are very aware of how the code should be written and give you also the implementation details. Takes, for example, a language design and architect, you can add how many titles you want. Heilsberg, that is the designer of C#. He is, his value is total, is immense. And if you go to the TypeScript repository, and now he's working on TypeScript, you will see his own PR. So he is doing a pull request by himself. So there are many features that are coded directly from him.
It's awesome.
Okay, so an architect must have this kind of capabilities to have this title. Otherwise, he get lost. It's like an architect in building houses that or bridges that fall apart. Because he needs from the engineer that tells him, you cannot do that, because the bridge will fall down very soon. That's very dangerous.
Actually, I know some guys who plays architect role that doesn't have experience writing code, and you're absolutely right. It's a wrong direction.
It's terrible because you risk to have performance issues that cannot be recovered. You have to forecast a bit what does it mean from a versioning perspective, and what does it mean from the difficulty of maintenance internal on the team that is going to make the implementation. You often, the true architect provide an initial proof of concept, written by himself, in order to experiment and to see what is the best technology that can solve the problem. When you demonstrate that this is proof that can work, of course you need help from others. You cannot bring an entire product by yourself. But you have to provide a specific direction to the software engineer that is able to implement in a smart way a feature, provide the implementation with the performance, the right amount of performance, and so on. So there are a number of issues that must be carefully evaluated as an architect. And the experience, of course, it's super important. An architect must be able to give a kind of possible solution and probably even not the most obvious solution. Because, of course, an architect value can be seen when he or she can invent something that is not absolutely obvious. Otherwise, the other guys in the room can do the same pretty easily if there is a previous implementation.
How to do it? Just a few minutes ago, we had a talk with guys about interesting thing. They have to start writing some CLI tools. It doesn't matter the reason, but they have to write some CLI tools. And they has chosen Go because of fat binaries. And when we said, okay, but in .NET you can make fat binary too. So the answer would be, oh yeah, great, of course. But we didn't thought about it when we made this decision. So the question is how to know everything, because if you want to create fat binary, you can just say, oh, Go has fat binary. But if you don't know C#, don't know .NET, you can't choose .NET because you don't know how that in .NET you can create fat binary. Also, there is no way to know everything. So
of course.
The question is how.
But of course, in a group you can ask help from others. So the ability to have an architect also to get experience from external people. You can hire people also to ask them for an evaluation and to see if the change of maybe a technological change is worth the pain. Mm-hmm. I mean, even if your team is skilled in a certain technology, it doesn't mean that everything can be solved with that specific technology. So you have to be very careful and evaluate other technologies as well. A good friend has his own company in Romania, and he evaluated a lot of languages in order to write kernel mode drivers. And at the very end, even he was not proficient in Rust, ended up in choosing Rust for good reasons. So he had a technological shift and decided to go there just because the evaluation brought him to go there. This is a good decision. He is a good architect.
Actually, technology switching is sometimes can be considered as a dream for a lot of developers, because I know that there's a lot of developers who want to switch from C# to Kotlin, just because this language is a little bit the same, but Kotlin has more features. And usually when we're talking about technology switching, the main problem is how to sell this idea to business. I mean, sometimes business are very, very afraid how to deal with this technology switching. I mean, how to find new developers and so on.
Yeah, of course, supporting a technological switch is a cost.
Yeah.
So you have to carefully evaluate the benefit and the cons. Because if converting all the team in a different technology is worth the pain, why not? But you have to carefully evaluate, because when you switch, then coming back is hard. So it depends from the pieces of the architecture. I mean, talking in general and is difficult to say. Every use case is substantially very, very different. Yeah. For example, I will make an example that is very important. Code generation. Uh-huh. Something that I love in a particular way. I use it in many projects to code generate a lot of parts of the application in order to make it survive from versioning and evolving, ability to orchestrate business logic and so on. But when you decide that code generation can be a solution for your application, then you have to carefully evaluate what are the main platforms where code generation can happen in a decent way. And for example, in this way, Wlaschin is probably the best compiler for code generation, because it has a very strong support. It's a kind of compiler with a box. The box is open. It's no more a black box with all the possible APIs exposed externally. And this is not the only tool available in .NET. There are also expression trees that can scare many people, but after all, they are extremely powerful and very performant. So there are many things to evaluate. So if I had to choose a language between F# and C# for a project, F# does not have this ability of code generation just because it cannot leverage Wlaschin. So it's automatically cut away from my evaluation if the code generation is one important option. And even C++ is cut away, because, I mean, generating C++ on the fly, it's a huge cost. It's very, very difficult.
Yes.
And so, I mean, these are the kind of... What about Kotlin? I mean, do they have code generation? I mean, I should have an external opinion about that. And this can be something that can really make a difference in many projects.
Yeah, it's a good point. And you mentioned a good thing that's according to your experience, you like code generation. And but there are a lot of projects that doesn't require code generation. And can you share your idea how to deal with such an influence from experience? Let's make an example. I'm a .NET developer, and I have some experience with JavaScript. And if I want to make a UI, for example, doorstep UI. To be honest, I would deal with .pf, for example. I will think about, let's choose .pf or Electro. And it happens due to my experience. It happens due to influence from my experience, because there are a lot of other desktop frameworks. But as for me, I'm afraid I will not think about this framework. So what do you think? How to avoid such a negative influence from our experience when we use the approach, when we use the technology, and we're trying to continue using this approach and technology for new projects instead of taking a look to new ways? How to be a clear-minded?
It's a kind of personal approach that, I always believe it to be open-minded from this perspective. Many friends asked me, how can I write a mobile application? And I said, frankly, I don't like too much the Xamarin approach, for example. And I said, the reasons, because, they solve the problem, but the complexity is probably less if you use other tools. Like React Native is one that is very popular, as well as the Progress one that has the native script as well, is extremely interesting approach. And I love native script. By the way, I wrote a few applications with that. And frankly, if there is a better tool that fits my use case, okay, I cannot use my favorite language, who cares? The priority goes to the customer. So if I have to pick the right choice, I go that way. So
how to do it?
You have to be objective, because the goal of building a good application comes first. I am not a fanboy of a specific application or a language, so that I want to do everything with that. But I found over the years that C# fits very well in so many fields. That is still my favorite language. And for many things that touch the native ground, C++ is still my favorite language there. And so, I have a good complement between the two, and I can fit a lot of things. When it goes to mobile application, probably I will go to native script or React Native using TypeScript, because JavaScript scares anybody.
Yes.
The maintenance, obviously, I don't want to kick off just for joking with anyone, but it's a reality in a language where you can type var false equal true. I'm scared, literally.
Yeah, and but when we are talking about young developers and junior developers, you mentioned that they like JavaScript. Also, young developers likes Python, and so all these languages have dynamic typizations.
Dynamic is just, in my opinion, the laziness not to use the compiler.
Yeah.
That's it, because you have to understand how the compiler works. You have to understand that you have to produce some artifacts. And on your disk you see these artifacts, and what are they? You have to study to understand.
Yes.
Instead, it's very handy to have the ability of double-click a file and then it just runs, and there is some magic that produced me the hello world on the screen. But it's not the right way. TypeScript nailed it, because you have both the strong typed word and the dynamic behavior, so it's a good compromise in that sense. But after all, my experience tells me that I want as much as errors as possible at compile time. I want tons of errors at compile times, because they are all problems that I won't have at runtime.
And what do you think about Robert Martin post about Kotlin, that he say that Kotlin is not exactly a good language because of very strong typization, and you require satisfy compiler, spending some extra effort satisfying compiler instead of just writing extra tests?
Well, I am not enough. I have not enough knowledge in Kotlin to judge this, but I am also scared about the people saying that tests can avoid bugs.
Mm-hmm.
I mean, that's in theory, yes. In practical, it will not happen. You will never find a manager giving you enough budget to have a code coverage in test that is satisfying for your application. So being forced to have certain restriction at compile time is an opportunity. Is not some lost time. I mean, you're not throwing away time from the developer group. You see how many fault pages are around the internet with the CSS and JavaScript mistakes.
Yeah.
So, I mean, this is the proof that it's an utopy pretending that test will work and a good way to work. If there was a compiler behind these guys, we won't have such a long list of errors. Cannot stop all of them, but mostly yes.
What do you think about mutation testing? Can mutation testing? If we add mutation tests, maybe it can help us writing enough tests. Just run mutator and check.
It depends from the application. Basically, it's too complex. It's like testing concurrent code. You can or you cannot. It depends from the code that you are testing, because certain. Many years ago I did a concurrency session where I showed that on my machine I could pass all the tests systematically, and as soon as I switched, I added a line like a console write line or something like that. All the tests failed. And if you do these kind of tests in a virtual machine, which is more and more popular, you end up in having even more trouble, because the scheduling on a virtual machine is more predictable.
Yeah.
So you will have the same run with the same sequence of scheduling the threads. There is no randomization at all. Even if you run the test all night long, you will have the same sequence, exactly the same sequence repeated with no value for the tests. So, it's extremely difficult to give assurance based just on tests. That's why I always recommend to young developers that at least once after you wrote some code that is pretty hard, they should code review themselves and say, okay, and now debug your own code just reading it. But you have to reread your code at least once before hitting the first time F5. You cannot just go and hope that it will work anything. Just look at it, because maybe it works.
Yes.
But the code is crappy, is pure luck that is working. And this is happening quite frequently, by the way.
Couldn't agree more, because when we are writing articles, there is no way to release articles without reading it again and again and again.
Of course.
And I don't know, when I write articles, and usually I send it and show it to my wife, and sometimes she said, have you ever read it?
Yeah.
Yes, I read it twice. Come on, how did you miss this mistake, and this sounds awful. Do you really wanted to say it? Yeah, I think it's the same code. Actually, that's all from my side. Thank you. That's
Thank you very much for hosting me.
Yeah, this was very interesting. I think that is very useful for our listeners because, and that was very useful for me. I found
Let me spend one word for the Moscow user group .next.ru. .net.ru, which is the Russian .net user group.
Yeah.
And I want you to take advantage of knowing them because I think that they are doing a great job. And yesterday I was hosted by them, and they gave a session for them. And so the community is a good way to compare and brainstorm ideas. And
yes.
So one strong advice that I want to give to any developer, please go to the community meetings and meet your peers, compare your ideas with others. Brainstorming is the core part of our work. It's so important.
Yep. I couldn't agree. Thank you. Okay, hello.
Hi.
Here in our studio, John Galloway. I don't want to say who is a John Galloway because you should know who is a John Galloway. And can you answer the question? Do you know why WinForms at WPF has been chosen to porting to .NET Core in .NET Core 3, but WCF and WWF has
not? Yeah. Well, I think, it's always a hard question. I have mostly, I don't have the exact words. I don't know the exact thing, but I can tell you why I think it makes some sense. Right now, there are better technology options for WCF and WF. WCF, we're recommending people use gRPC now. A lot of things, like if you think of WCF, this goes back, to technologies that were in .NET way at the beginning, early 2000s. And over time we've learned that there's kind of better patterns to use. So whereas for desktop there isn't. Desktop is a little harder. It's a little more difficult to say, well, rewrite everything to what? Do you do WinUI or UWP? Or there's places where people really need their WinForms and WPF. I think also, I'm not going to say it's easy, but it's maybe a more confined problem for those. So, but I think really the main thing is that, if we've got somebody with a Windows Forms application, to be able to say, hey, you can update this and run it, update the .NET part of it to run on .NET Core and get huge performance benefits and not have to rewrite your application. That's really, helpful. And then the services, you're probably going to be better to update those. I've had a lot of conversations here about WCF, and one option is update to use gRPC. Another option is if you can keep running the WCF parts on .NET Framework. Those are still supported. Yes. And you can use .NET Standard to share code between. And then there is also a project, the Core WCF project.
Yes, that's why, where initial piece of information about getting rid of WCF and .NET Core was about, we can't do it because of Windows, because of lots of Windows, but according to WCF Core, it looks like, almost plain old WCF without some of features, if I understand correctly.
Yeah, I think there's a difference between Microsoft, recommending a project and even the way that Core WCF started was an engineer at Microsoft started working on a port to .NET Core and made a pretty good start on it. And Microsoft decided, instead of making it an official shipped part of .NET Core, to contribute it to community. And so the community is running the project, but this developer, Andrew Kanu, is continuing to work on this project. Like Microsoft, as part of his work, he's working on this project. And so it is something where, we do see it's important. It's just, when Microsoft ships something, they have to support it for a long time, and people expect, all kinds of, WCF has all kinds of transport mechanisms and a lot of, there's a lot going on there. So.
And I liked it because you could, create the same endpoint and with different bindings, and we have TCP, HTTP by, applying one piece of configuration. That was awesome.
Yeah, I know. That is tricky, and it is something where, the kind of the main recommendation now is to move things, either if you can, if it works for you in .NET Framework, keep it there, or if you need to update it, then gRPC is kind of a more modern, and you do get big performance benefits.
Yes.
You also get more interoperability because gRPC is very modern, works on a lot of languages. A lot of companies have gRPC services. There's more tooling, that sort of thing. So it's kind of more,
And problems with infrastructure due to HTTP too.
Yeah, exactly.
And some, issues with AWS ECS. But yes, I understand. No, it's true. And you mentioned a good point about community. Mm-hmm. Let's have a talk about open source and .NET Foundation.
Sure.
Because I remember your last presentation, the previous .next, about open source, and maybe it's kind of tricky question, but from usually when I'm talking about developers are trying to go to open source to improve their CVS. Let's be honest. It can be a good driver for developers.
That is a reason, sure.
Yes, and what can you say from your point of view, is it mandatory for a good developer, experienced developer, not a junior, a middle developer, senior developer, having a contribution to open source projects? Is it?
Well, it's hard to say anything is mandatory. There's a lot of different ways to be successful and happy as a programmer. I very much recommend it. It's how Microsoft is developing, .NET. It's a great way to interact. It's a reason why when I come to Moscow and talk to people, I have, common things to talk to people about. I have friends here that I've never met in person, but we've worked together. It is a great way to learn. And it's also a good way to avoid rewriting the same code someone else has written. If you are working with .NET open source regularly, you'll, instead of me writing my own mapper software, I'll use AutoMapper. Instead of me writing my own OpenID Connect, I'll use Identity Server. And but okay, if you don't contribute to open source, it doesn't mean that you can't use AutoMapper. Well, there's definitely something where you can use open source without contributing to it. But I do feel like, as a senior developer, it's really going to be helpful to actually contribute. And sometimes a contribution can be as simple as documentation or tests. Or I very often contribute tiny pull requests. This past weekend, I was speaking in Istanbul. I was doing a demo on gRPC. I followed the documentation and it didn't work. And I found out that something had changed from one of the previews. One line of code needed to be changed. I sent in a pull request and they modified it. And that helps everyone else, right? That's an open source contribution. I learned, I save other people time. So I feel like that making that part of your workflow is really going to be helpful for most developers.
I have a friend who is working in some company that's developing a tool, open source tool, and he said that to get an investment for this open source tool, they have to show huge contribution. They have to show that they works fine. Their performance is good. Mm-hmm. How can they do it? By by increasing amount of commits. As a result, he had to commit every line of code, almost every line. Of course, it's not every line, but he said that I could make one commit every day, and I think it's fine. But to satisfy these requirements, to get more investment from investors, I have to make every commit, commit every hour, trying to figure out how to name it and so on. Yeah. And what do you think? If I understand correctly, GitHub is abusable. I mean,
yeah, it can be. So you can abuse any metric.
Yes.
Right? So there's going back in time. Like people used to focus more, and some places they still do, on lines of code. And they would say a developer is more productive if they contribute more lines of code.
Yeah.
So people would write a lot of really bad code.
Yes.
And sometimes the best code you can write is no code at all, right? If you can see how to solve a problem because you can see how not to write any code, or to write just a little bit of code, or to use a library that doesn't use much code. So the same sorts of things. There are, I do recommend not doing just one commit per day. I recommend doing more small commits, because that's not to make it look like a lot of commits, but because you can, it'll help you out as a developer if you're able to trace individual changes and not just say, did a lot of work for your commit message, but say, refactored to use an asynchronous parameter or something, right? Well, one of the most difficult things when you're understanding someone else's code is why they did what they did. And usually by looking at a commit history, I can see their thinking, and I can see what didn't work and why the code is set up the way it is. And I feel like as a developer, sometimes we want to hide the things, hide our mistakes. And I've been learning this more recently. I've been trying to do, I don't know if people do this much here, but Twitch programming, from my friend Jeff Fritz, he does this all the time. And I'm used to doing presentations where I sit in my, office or hotel room and I get everything ready, and I know exactly what I'm going to say, and then I go on a stage and I go through my script. And when I do a Twitch programming, oops, it didn't work. Let's go look on Google. Let's look at Stack Overflow. Why isn't it working? I don't know. And someone in the chat says, you forgot a semicolon. So we have to, as programmers, we have to be okay with looking stupid sometimes, because we all make mistakes.
Oh, couldn't agree more. I just remember one bug that I made in my pet project in dictionary initializer. Okay, we have a dictionary with enums. Key, and it doesn't matter what's the object. And enums can be sort, shield, and ball.
Okay.
So I've made dictionary sort object, sort object, shield, object, shield, and it works fine. Compiler didn't say anything because initializer with score brace usually reuse indexer. And there's no harm in assigning the same indexer 3 times. And when I took a look at this code, I say, how is it possible to make such a stupid code?
But we all make mistakes, and what's nice is that it's very easy to fix our bugs. It's very easy to make a new commit. I think going to your earlier thing, sometimes people don't want to contribute to open source because they don't want to feel stupid. And a lot of modern development with open source, with everything, is just being okay with making a mistake, and other people will help you and fix it, and we all learn. So.
What do you think? Is it not mandatory, but developers contributing to open source projects that are supported by .NET Foundation, or important for industry open source projects like ECU, NEAT, or I don't know, NEAT or JSON, or there's no harm in contributing to some any open source project?
Anything. No, I very much recommend contribute to things and work on things that are interesting to you. Mm-hmm. It shouldn't be so. What I think works well is if you are able to, in your work, if you're working with Newtonsoft JSON and you see something in the documentation that could be fixed, mm-hmm. send a pull request for that. Like, just do that as part of your work. But then I really think it's great to, if you can find an open source project that's fun or exciting, maybe a game project, maybe it's something where you're contributing to a Unity tutorial or whatever it is, uh-huh. right? Then do that. Yeah, obviously .NET Foundation, we can only support so many projects, and we focus on ones that are bigger, that are used more, because we're trying to do the most we can with the amount of time we have, the amount of money we have, all these things. But absolutely, as a developer, I think it's great to contribute to projects. It doesn't need to be a huge thing. Sometimes a small little pull request here or there, or a small issue saying, hey, I ran this and this doesn't work with this. It's yeah.
Yeah, it's a really, actually, it's very important, I think, for our listeners, because I've noticed that there is an influence for our decisions, because we think, okay, for example, cool guys are contributing to .NET Foundation project, so I want to be a cool guy. I have to contribute to this .NET Foundation project instead of trying to have fun.
I think programming has always been the best way to not get burned out, the best way to be productive is to have fun with programming. And if you can, part of having fun as a programmer is working with a team and you're all working together on something. So sometimes something that doesn't seem that fun, maybe a business .NET project, but you're working with a fun team. Maybe you're working on getting a release out and you're excited about that. But very much a lot of the time, if you're interested in music, if you're interested in, games, if you're interested in, making something really fast, performance optimization, these sorts of things, find something that's fun, and it doesn't have to be a big deal. Like, you can go in and say, hey, look for a help wanted issue, look for something small, or just offer, hey, I would like to get involved. What's something I can help with? And sometimes it's typing up release notes for a release, or it's writing some unit tests, or it's updating some documents, and that's a great way to learn. I've talked to so many developers that have done that. They've said, hey, I want to get started. They worked on documents, and then over time they've picked up and they're running the project or whatever, right? So it's, yeah.
Actually, I just want, for our listeners, I want to add that .NET Rule community wants you to contribute to our projects, so that it's a good entry point to open source world. Mm-hmm. Yeah, and we have a limited time. I just have a small question. Sure. It's about can you share some insights about open source? Because when we're talking about Microsoft technologies, from my point of view, Microsoft used to be a kind of the company, not exactly open sourceness company 10 years ago, for example. Yeah. Who did these changes? Why? I understand why this made because of modern world. Yeah. But can you say? Is it only Satya Nadella influence, or there were some? Or there are a lot of influencers in Microsoft, not only Satya.
Yeah, definitely a lot of people. My boss Scott Hanselman, he's pushed for open source for a long time, including explaining to developers why it's important, being in the community in that way. Scott Guthrie has definitely been a big supporter of open source. Going back to early things with ASP.NET MVC, supporting that. And as he's moved up at Microsoft, he's continued to push for and support open source. Satya has been a big supporter. People along the way, Phil Hack in working with ASP.NET MVC. So a lot of, I could go down a list. There have been a lot of people at Microsoft. For a lot of us, we've been excited about .NET open source for a long time and pushing for it. And it's just taken, years and years of working from the inside. Also, there have been a lot of people in the community who have built a strong open source community who have pushed Microsoft in the right ways. So I don't want to just say it's just Microsoft that's doing this. It's all of us working together. That's been really good. So
Okay, thank you. If I understand correctly, there are a lot of people, and I suppose in the future we have a lot of interesting things. Let's have fun.
It sounds good. Yeah.
Thank you. Thank you. That was very interesting. Yeah. Sorry for limited time.
Oh, that's great. Thank you.
Hi. It's .NET More podcast, and in our studio we are going to have a talk with Christophe. Christophe Nasarre.
Yes, Nasarre.
Nasarre, yeah.
It's complicated to say.
Yes. Yeah. I'm sorry.
No problem.
It's hard to pronounce. And it's a person who provide a very extremely interesting presentation about .NET metrics. Counters in .NET Core and this cross-platform counters. And first of all, may I ask a small, just tiny questions? Does it really works?
Yes. So what I presented was the kind of monitoring pipeline that you can use now with .NET Core, and it relies on the event pipe. So it's a new channel of communication that has been implemented just for .NET Core starting in 2.2, and now it's available in 3.0, and you can get counters and you can get traces. So it's working. It's pretty efficient. It's working based on inter-process communication, which is an M pipe on Windows and sockets on Linux. So it's working and it's cross-platform. So it's very, very efficient.
So and anyway, it's under the hood. It works in different way in Linux and Windows. As a result, on the different machines with different operation system, the results of this tracing can be slightly different.
So, in fact, not really, because it's just the channel of communication that is different. But the generation of the event or the generation of the counters are the same. It's the exact same code in the core CLR. It's just the way the payload of the event or the payload of the counters are sent through this pipeline. So you should have the exact same performance.
And so also as far as I remember, when .NET Core has been presented, there are some presentations from Sasha Goldstein, for instance, about how to profile our application on Linux.
Yes.
Platform-oriented profilers. Can we use this general approach, general traces, and is it enough?
Yeah, that's a very, very good question, in fact, because when we moved from Windows to Linux, we were used to have some dedicated tools. We are using .trace from JetBrains as a profiler, and it's really the one that we are using the most. And when we went to Linux, we end up having almost no tool. So I would separate the different kind of tools.
Yeah.
Based on your question, the one that I presented this morning about monitoring how your application is behaving, which is mostly the trace. And the traces is not really about profiling. It's about getting metrics about the exceptions, metrics about the allocations. So this is, I would say, enough. compared to your question. This is really what we are using internally. We are using the same mechanism on Windows, and we are using the same mechanism on Linux. So for monitoring, it's really, really what you need. Now, in terms of profiling, you have different options. I had a demo during my presentation where I show that if you take the trace with the profiler as the source, the sample profiler as the provider, in the trace you get the call stacks of all the threads that are taken every millisecond.
Yeah.
So it's kind of a sample profiling. This is not the most accurate one, but it could be enough. And as I've shown this morning, you can see the result in Visual Studio as a profiling session. So it's good for CPU.
Yeah.
CPU sampling. If you want more, if you want what you get with .trace, you don't have the same stuff today. But I've just discussed, after the presentation, the guy from JetBrains came, and I asked them the question yesterday. So they came back today, and they tell me that with the last version of what they are showing in the preview, there is a new console application to take the trace. So maybe we will be able to get the same level of feature both on Windows and Linux. I will have to try it when I go back to the office.
Yeah, it's really cool. So we can get rid of performance counters. So we can get rid of some. We don't really need learning Linux.
I mean, it's a different point of view. What I mean is, I'm a Windows guy for many years, and you need to go to Linux and you need to use Linux. You need to get used of the usage of Linux, which is sometimes very different from Windows. And when I first started to play with Linux, it was really a nightmare because the simplest thing was complicated for me. But anyway, you have to learn the new OS to Linux. You have to learn some of the new tools. Yeah. But things will be better and better in terms of tooling. Microsoft is doing a lot, is investing in these tools. I have shown in the talk today, and I'm guessing that they will continue to offer more and more feature in their tool.
And you mentioned this as you're I would say Windows guy.
Yes.
Yeah, and I would say, let's be honest, the majority of .NET developers can be considered themselves as Windows guys. And it's really hard to change mindset from Windows approach, for example, going to performance monitor and clicking performance counters and so on.
Exactly, yeah.
Linux approach. But we shouldn't do it, don't you think?
I think we don't have the choice. Linux is now one of the operating systems that is the mostly used for containers.
Yes.
For example, even in Asia. So you have to learn these I would say new for us operating system, but it's been here for many years. And it's like when you learn a new language or something like this. It's hard at the beginning. You have to change your habits. You have to get used to the new tool. But I think it's a great opportunity to learn new ways to get information. For example, as Windows people, we are used to work with APIs. Okay, we have object models in C# or APIs in C++. And in Linux, you can use a more like a file-based way of getting information. So if you want the list of the processes, you just open a file that contains the list of the processes.
Yeah, and everything is a file.
Everything is a file, so it's very generic. So for us, at the beginning, it seems like a little bit more complicated, but if you think about it, it's another way. And it's also providing more feature that you had on Windows. What I mean is you can chain some operation based on files. You can just pipe, you can grep, and this is something we are not used to on Windows. So it's another stuff that you are learning and that bring you more feature.
Yeah, and can you suggest some book or some materials for our listeners who want to learn Linux and learn how to use it properly to change their mindset?
That's a great question, because I asked that same question to my colleague, and I said I'm reading books. and I'm reading a lot of books, and I was expecting to get such a book, but I didn't find any equivalent of, I would say, the Jeffrey Richter kind of book or Windows Internals to understand how the files are working, how the threads are working. So I'm still looking for this kind of resources. You can find a lot of documentation on the internet. So the guy from the Linux at the office, they said, yeah, you can read the man. So the page corresponds to the man. But it's a different way of presenting information, more formal than we are used to with the books that we have for .NET or for Windows.
Yeah.
So I can't give you any link on that. Sorry about that.
Yeah. Actually, I mean, it's kind of not strange, but it's unexpected because we usually... I'm fond of reading books.
Yeah, and we also are used to the videos kind of stuff.
Yeah.
We are using a lot of videos now to learn new stuff. I didn't find a lot of videos about Linux, I mean, at the lower level, but you can find a lot of discussion. They are very active on Stack Overflow. You can ask questions and you will get a lot of answers. So it's very close to what we have today with .NET and with C++. So you should go to Stack Overflow and ask your Linux-based question there.
Okay, thank you.
Yeah, you're welcome.
Yeah, and okay, let's get back to profiling because I like this topic because when we're talking about profiling, finding what exactly happens, especially if we have some performance degradation, I've noticed that there's no way to profile something without strategic approach, without having some strategic approach. What do you think? Do you follow some strategic approach to profiling, to finding performance issues in your work, or checklist or something like that?
Yes, I think you're right. Using a tool like a profiler without a more high-level approach, it might not be as effective as if you have something to do. So what I mean is, usually when you are debugging or profiling, you are trying to solve a problem. So the first step is to find where the problem is.
Yeah.
Okay, and it seems obvious, but think about why would you need a monitoring system? Basically, it's like when you go to the hospital, you have your heartbeat, you have your blood pressure, you have the oxygen, and so on. And based on the values that you get, you know that the problem is maybe in the kidney, maybe in the brain, maybe, I know nothing about medics, but that's something that should help you start your investigation. It's exactly the same with applications.
It's like if you are trying to cure yourself, instead of going to hospital, you can say, I have a headache. Let's try to eat aspirin.
Yeah, exactly.
It's like, I don't know why, but I try to cure it.
Exactly. So that could be a problem because that's why we are going to the doctor. I mean, they are studying for many years, and so they know the kind of problem that could end up using this kind of medicine. But for the troubleshooting part, which is a more general term, you always need to start from a diagnostic.
Yeah.
Okay. So I'm looking at my monitoring dashboard. I see that the number of exceptions is growing. What should I do? I should try to figure out what are these exceptions and go into my source code. That's the way you build your investigation. So when it comes to profiling, it's usually when you detect that, for example, the CPU usage of your application is growing. So you are taking like 80% of the CPU on the machine, which is not expected. Or if the request that you are processing are getting processed slower and slower.
Yeah.
So
we require alerts and tracking of these events.
Yes, so you are using the kind of events that I mentioned in my talk to figure out that, but usually you are also using high level or what we call business metrics. Mm-hmm. And the kind of business metrics is the number of requests that your server can process per second, the duration of the request, and see if these stuff are changing. Then you try to find correlation. What I mean by correlation, I mean what could explain that. So, for example, it could be that you are allocating a lot and the garbage collection is triggered many, many times and the suspension time grows, and so it takes some time from your own processing. Or it can be exceptions, or it can be contention of the threads, meaning that your code is not well coded and the threads are waiting for each other to process.
Yeah.
And this is where you need to find the right tool. For the last part, yes, maybe a profiler could help, because the profiler will show you which thread is doing what and when, and so help you to find this kind of information. But for the problem about memory, well, a profiler won't be very useful for you.
Yeah, and actually also when we're talking about profiling, if I understand correctly, I suppose we should try to use it on staging or production, or try to reproduce environment and all infrastructures that are very close to real production.
Yeah.
Isn't it?
That's a good question, in fact, because if you read the book, it's always like this. You are pushing a new version, you are doing some testing, performance testing on stages, everything is fine, you send into production. That's not the real life. In the real life, you do this, you find nothing, you push in production, and since in production you have a different load, you have different datas, then stuff behaves in a different way.
Because you have a different servers, because having the same servers in production as we have in staging, having the same servers in staging that we have in production, it's too expensive.
Yes, exactly. So that's a situation that you have to face from time to time. And in that case, yes, you have to do some profiling in production. Mm-hmm. So how would you do that? You have, for example, .trace. You can just copy a tiny binary on your server machine that will collect the traces and the profiling, and then you will analyze with the .trace user interface. Mm-hmm. This is what we are doing. But usually, since in production we don't want to impact the business, we just collect that profiling information for, let's say, 30 seconds.
Yeah.
So for a very short period of time, we don't impact the production. We don't need to install a lot of stuff on the server because the IT won't allow this also. Okay.
Especially security.
Exactly, security. So we just install one tiny binary, we get the trace, and we analyze them on our developer machine. So yes, in unreal life, in our dream, we should just do that in staging phase, but unfortunately sometimes we have to do it on production.
Yeah. And so when we talk about Windows, it's okay, let's use RDP and so on. But when we're talking about Docker, there's no harm in attaching to Docker container via SSH. But sometimes our infrastructure, especially if we're talking about AWS, ECS, doesn't allow us to do it.
Yeah.
And imagine you have some services in Docker, and you can't attach via SSH to Docker container. And what should you suggest? What can you suggest in this case? How to collect tracing, how to collect performance metrics, how to attach profiler to container in this case.
That's a real issue. So we are not using these kind of containers. We are using Mesos and Marathon, which is another kind of like Kubernetes or something like this. So we have dedicated containers, but we have the same limitation. Mm-hmm. Our IT guys won't allow us to have SSH daemon running into our container. And the example that we had was, okay, I want to remote debug my Linux application. You can do this with Visual Studio. You can just install the binary on the container and open, you have to have SSH. That's how it's working. So we faced this problem, and we had to implement another way to communicate between the Windows machine and the container. And we were able to do that with WebSocket. So in fact, with WebSocket, WebSocket is fine, it's just HTTP.
Yes, of course.
And the guy of the IT said, okay, we can open one additional port. And so we had to implement the equivalent of what SSH was doing ourselves.
You created your applications that use SSH like WebSocket?
Yes.
Wow. Have you considered idea making it open source because it can be extremely useful?
We didn't think about that, but why not? Yeah, but it's only for the Visual Studio debugger.
VS
okay. Something, host or something like this. So we did that just for the remote debugging. For the profiler, we have like console-based access. We mean that through a navigator, we have an access to not an SSH, but to a console with limited rights. But the rights are enough to start a profiling session, for example.
Oh.
Okay? So that's another way. You can go through that way. This is how our IT people help us to do so. But I will keep the idea of making the WebSocket stuff public.
Actually, the thing that you are talking sounds like showing candy for us. I think. Okay, but I keep it for me. So we will think about it and see if we can make it public. We've done many changes that are public, so maybe we should be able to do this. Right now, it's bound to the way we are installing stuff into our container, but we can see if we can just extract the code to be usable by anyone else. This is a good point. For example, we have here John Galloway.
Yeah, exactly.
I suppose the foundation can help with supporting. And also, when I'm talking about open source, there is a .NET community, and we have some projects, and we can help with this open source activities too. So .NET Foundation is too huge for this tool, because really it's dream for us, because debugging to containers
is a nightmare.
It's not only a nightmare, it's a dream. I mean, it's a dream. Debugging to containers. I understand that it's slow, but it maps the speed that you are debugging stuff. So you don't need to have very fast access. But you just need to make it work. Yes.
And we just get it. Yeah. We'll think about that.
Following the question about materials, I mean, I like asking for materials and getting information. When we're talking about profiling and performance investigation, what can you suggest for our listeners what they should learn? Because there are a lot of books, for example. I don't know. Product not benchmarking. It's a book that I don't know. You can see this book in this conference in each community or company stand, because of and but anyway, something that can be considered as a good entry point to performance profiling for our listeners.
So I would say two books. You have one book that Sasha Goldstein was co-author. I don't remember the exact name, but I think it was from A Press.
Yeah,
it was from A Press, like performance .NET application. But look for Sasha Goldstein.
I know this.
He is one of, and I really like the book because it brings both the theory and how to use the tool. So that's something is really, really helpful. It's not about like just reading stuff. You will be able to very quickly apply what you are learning.
And it starts with tools.
Yes,
the first chapter of this book are about tools.
Yeah.
And only the next chapter is about how method works, how garbage collector works, and
exactly.
So on. Yeah.
So this one is a very, very good one. I think there is another one from Ben Watson, also about performance, which is more recent. I think the second edition of the book was published this year. And then, okay, your question was more about performance and profiling, but you can also use the book about debugging. There is a book about debugging, which is like a gray with some green. You have two versions, one for the native debugging, one for the .NET debugging, from a guy from Microsoft. And it's very, very interesting because, again, it explains the theory and it gives you the tool and how to use the tool. So to start learning how to do stuff, this is very, very good.
Okay, got it. And I suppose it's enough because I would say it takes a year reading these books, and after that, I will ask for the next reading.
For more books. Okay.
Yeah. Do you use some performance test or something like that as quality gates, or do you think it's a performance? Can be considered as a quality gate?
That's a good question. My answer will be it depends.
Yeah.
Okay? Why it depends? Because not everyone need to have this level of requirement. Yesterday we had a bird of the feather discussion with the attendees, and it was about performance, and we get almost the same question. And so it really depends on the SLA that you are pushing to your application. Yeah. So if you are selling a server application that is supposed to handle, let's say, 200 requests per second, you need to ensure that the time you spend to answer the question, the request, fits into this SLA. So it's meaningful to build your framework to measure that. But the problem with this kind of application is that you need to build like integration tests.
Yes.
The whole system. Are you calling databases? How do you take into account the time spent to call a database? Do you measure it? Do you like fake the call to the databases? This could be very complicated to build. So if you need this kind of service level agreement, then yes, you need to build your own testing and start with the unit test frameworks that exist today, or use like benchmark.net, which is a great framework to do kind of unit test, but at the performance level. It's very, very nice. So I would suggest to start with it, see if it's enough for your SLAs, and grow as you need more.
So it's a really good point. So it's the same as we have with functional tests. We can start with unit and go to integration part. So, okay, if we're talking about performance, usually and integration tests of performance, usually we're trying to run these performance tests on environments, on the staging environments with different different CPU, different amount of memory because of costs and so on. As a result, what do you think, is it possible to scale properly SLAs for different environments?
No, I don't think so. I truly believe that you need to have the same environment, the same physical environment, the same load. Otherwise, you are comparing orange with potatoes.
Yeah.
It just doesn't make sense. So I know it's more expensive, and that's one of the reasons why not everyone wants to do that, because it's expensive, but it really depends on what you are selling to your customers. And if you want to be sure that what you are giving or selling to your customers reach the bar, you will have to build stuff like this. And for server application with a lot of connections like databases, caches, and all that stuff, you might also use what we are doing internally at Criteo. We are using what we call A/B test. So the idea is that on the same hardware, you are running a different version of the application, meaning the new version that you want to test, and you compare the metrics, but not the low-level metrics. You are comparing the business metrics.
Oh, it sounds like blue-green deployment with extra performance.
Maybe it's like you have two categories of request. Okay, so let's say that you have 100% of your load that is coming. You take 20% or 5% or 2% to this new version on the server. Then you compare with the 95% that runs on the normal version, and you compare not the low-level metrics but the business metrics, because this is where it's important. This is where you will detect that your SLA is good. It's not on the number of exceptions. Nobody cares. Okay, what they care is that the business metrics, the money that you get by analyzing and processing the request, is the value is good. You don't have to go any further. It's the value is not good. Then you start a performance investigation. That's how we start the investigation.
Yeah, got it. And but what happens if after for example, we release new version of application and it suddenly started to extremely popular, and as a result we have a lot of alerts,
consumption and all that stuff.
Yeah. No, but it's not happens because of issue with the performance that we made, but it happens just because there are a lot of clients started using our application. How to deal with this situation?
Okay, so again, that's why you need to make your test in an environment that is very close to what you have in production. Because if you don't do that, you end up exactly in what you are describing. You ship, it was perfect in staging, okay? Because maybe you tested against 10 customers, and now you are going to production and you test against 100 customers, and the problems start to begin. I mean, the first thing is how much does it cost to you? If it's expensive, just roll back. This is the kind of stuff that we are doing. We just roll back and we start to measure on a dedicated server with the new version that was not working as expected, and we start the performance investigation then. But we don't want to lose money, so we roll back as soon as we can, and then we try to figure out where the problem could come from.
Good point. Especially some kind of feature toggles can help or something like that. Talking about money, I love talking about money. What about today? We use clouds. Do you use clouds?
No, we don't use clouds. We don't use Microsoft Cloud. We don't use Google Cloud or Amazon Cloud. We have our own data centers. I think we have like 7 data centers now with, I don't know, maybe 35,000 servers that we are managing and where the applications are running. So we are owning our own cloud, if I could say.
Private cloud.
Private cloud, yes.
So, anyway, it doesn't change my question.
Okay.
I mean, we used to have some kind of joke that instead of trying to fix performance, let's add extra core. And it's a funny joke, and sometimes it's not a joke, because usually adding extra core in some cases are less expensive than allocating developers' efforts fixing some performance issues. But today we are working in cloud world, public cloud world, and private cloud world. I think it doesn't matter, and it's easier to calculate costs of our code, and as a result, I mean, for example, Lambda or serverless, Azure Function, and so on. To execute AWS Lambda, while executing AWS Lambda, you pay for time and amount of consumed memory. So, if we're talking about performance, what do you think? Applying some quality gates to developers with allocating extra effort fixing performance to reduce costs can be considered as options.
Yeah, it's always a balance. As you said, is it worth spending the time of one developer for like 1 week working on this compared to the price you would pay by the additional memory that is consumed by the application? At least now we can measure that, because you know that if your application requires 2 gigabytes more, then it will cost you, I don't know how many thousand of rubles, you know, and so you can at least now measure the time. Before that, you own your server. It's not really that important, okay? But now we have dashboards where the guy who are pushing the money on the table, they can measure and say, okay, you know, you should work a little bit on memory you are consuming, because if you save us 1 gigabyte per server, we will avoid losing that amount of money. Mm-hmm. So this is a good opportunity for us to push the requirement of the performance. But again, we need to base that on number. Always measure.
And it's a good question about measure, because we're not trying to measure performance of developers, not performance of code that developer by developers. So, sorry for mixing everything. So if we're talking about performance of developers, it grows the more time developers spend investigating, profiling, and so on, the better performance it will have. As a result, I mean, at the beginning, if you understand, okay, we need at least a week to fix this performance issue, and as a result, we will get, we can, save $100. And come on, 1 week, it's too much. We will never get back this money. We'll never get this money back. But during this week, our developers learn a lot of things, and as a result, for the next task, they can start using this optimization approach. They can start using Profiler as a standard tooling, like we have unit test right now. Everyone use unit test right now. So I would say usually when we create work items, product or PBIs and so on, sometimes it doesn't contain task with a create unit test, because it's obvious. We should write unit test. And the same with profiling. Maybe, what do you think? Maybe allocating some extra time learning and training developers using Profiler as a part of regular activities will help us automatically reducing costs for our system without dramatically increasing development time.
Yeah, I really don't know. Okay, you're preaching. I truly believe that you always need to have part of the team that is working on the performance of the code that you are writing, and this is also part of the code review process. When we push a review that contains some modification, other member of the team has to validate the change that we are doing. So the guy who are used to the performance patterns that we know are not that good could provide some feedback, so we can at least start at the code review level. Mm-hmm. Then if you want to dedicate more time on this, I think it's easier to convince usually the management.
Yeah.
Okay. But not only the management, because in different teams, I have already see cases where the developers don't want to spend time learning how to profile, how to do something like this. They just want to write some nice C# code, the new async await stuff, and write application like at the business level. So it really depends. But usually the most complicated part is to convince the management that, as you said, we should spend 5%, 10% of our time, like half an hour per day or an hour per day. I would suggest to do this kind of stuff, like dedicate, for example, every Friday. Okay, every Friday at the end of the week, normally everything is done. You can dedicate one hour to the team to spend on some of the issues that have been found during the week, and learn the tools and ask the guy, because usually you have like one guy or one lady who is interested in doing the profiling stuff, and she or he will very happy to teach the other how to use the tool. So I would suggest to start small, to use the tickets that you get either from bugs or from requests from the customers, and transform them into performance tickets. And that way, the team will be used to think about quality of code with the unit test, but also the quality in terms of performance of the code. So everyone will start also thinking about the effects on the performance, and don't think that the performance is only at the unit testing level, I would say, at the function level. You also need to think about that when you do the architecture. Yeah. Because usually the cost when you miss something at the architecture level can be much, much higher than then optimizing this tiny algorithm that is used in a tiny place of the code. Yes. I'm not saying that you shouldn't do that, but you should also think about the architecture as the root cause of most of the performance issues.
Yeah, it's like my favorite. It's like a story of some of my performance investigations that we had just a very awful example of using reflection, and I didn't touch this code during half a year because all performance metrics show that yes, it's awful, but it doesn't execute it a lot. And from architecture perspective, it's not significant to change it.
Exactly. Yeah. Always measure, never optimize before measuring. Yeah. Pre-measure optimization is hell, something like this. That's one of the sentences we have. So this is what is written on the book. It doesn't mean that after having working on optimization and performance optimization, you know the pattern that are working good, you know the pattern that are not good. So it's not like pre-measure optimization. It's that you know which data structure you should use to be more efficient. Yeah. But you shouldn't start by pre-optimizing everything.
Yeah. Thank you. I mean, it's a very important thing that we discussed, and I think we should rethink it.
Okay, my pleasure.
Yeah, and so thank you. Do you have some questions?
I would like to thank you to spend the time to ask this kind of questions, because it's usually the performance is not usually the topic of discussion during conferences, and this is also what I really like the .NET conferences, because we get a lot of questions related to the performance, the profiling, the debugging when stuff starts to not working as expected. And I think it's very, very important, so I'm very, very happy that you asked me to answer your question. Thank you very much.
Thank you for answers.
Thank you.
Okay, get back to our studio, and here is Pavel
Yosifovich.
Yes, oh, I'm sorry.
It's okay. It's a long name. I forget it sometimes myself.
And guys, you know, he's author of the book .NET Internals.
Windows Internals.
Windows Internals. Yes, it's a very long day. Yeah, and I have some questions, and the first question is related to your presentation. How long .NET can continue being so long to come?
Well, I don't think .NET really doesn't have much to do with COM these days, and in fact it never really did. But my talk is about writing a .NET profiler, and the profiler is still using COM, but really it's not full COM, like full Windows COM that uses registry and stuff like that. It's the concepts of COM. That means using interfaces to sort of separate a contract from implementation. So it's not really. It's just the concepts of COM, which are really universal in software development in general and not specific to Windows or to COM. So I think it's not that bad.
Yeah, cool. What do you think? Windows 10 is more suitable for developers. Windows internals of Windows 10 is more suitable. Does it suit modern requirements, or they, I don't know, went to a wrong path?
Well, I'm not exactly sure what you mean in the modern requirements, but nowadays Windows 10 is updated more regularly, so that's twice a year. Maybe that will go down to once a year because it's very difficult to keep up with changes and to upgrade very often, especially for large enterprises. But I think these days a lot of Microsoft projects are out in the open, they're open source, we know that about everything in .NET Core, and even some small parts of Windows are opening up. And I hope this trend continues and allows the developers to be more engaged even in the internals of Windows, which currently are still kept under sort of lock and key and are not open source. But because of the rapid update rate of Windows, then I think Microsoft is really listening, or at least much more listening to the community and to requirements and trying to make the operating system better. Now, of course, Microsoft sort of went back to its roots as a software company, so they don't really emphasize Windows as much as they did in the past. So for them, as long as it's their software running, as far as I can understand, then it doesn't matter on which platform that works, and that's why we have things like .NET Core, and we have applications that Microsoft has written for Android and iOS and all that stuff. So they're sort of saying, hey, we are a software company. We just want to make good software, so the actual platform maybe matters a little less.
Following the things that when we're talking about Windows, we know the funny stories about Windows and compatibility. I know you know the story about SimCity and reproducing bug of Windows 95. And if I understand correctly, modern Windows versions got rid of this idea with hardcore compatibility. So the question is, from your point of view, when you're talking about Windows internals, how much does it cost to keep such a level of compatibility, in Windows internals? Yeah.
Not exactly sure, because compatibility is really a tricky thing. Some of the stuff doesn't require much because they're being around for many years and they haven't really changed much. Some stuff is much more trickier, and so usually they develop something called the shim, which is sort of an adapter that tries to simulate an old behavior on a new operating system. And I haven't actually been deeply involved in this compatibility layer, but I know there are quite a few shims, and there's quite a bit of work being done on compatibility. And so this is still a concern. I think Microsoft is doing a relatively good job in maintaining all that. I'm not sure about Windows 95, things like a bit very far in the past, but certainly Windows XP and stuff like that. But again, from time to time things break, and the introduction of Windows Vista really gave developers and users some smack in the face because they were so used to XP, and there was a very large gap between XP and Vista, almost 5 years. Microsoft actually learned that lesson. You don't create that long gap because too many things change, and then people say, hey, I had my XP, everything was working fine. Why did you create that Vista thing? And that's one of the reasons that Vista failed in a marketerial sense. It wasn't a bad operating system. In fact, the kernel of Windows Vista Service Pack 1 is the same as the one in Windows 7, so it's not about the system itself, but it's about some other features that came in and people were simply unprepared.
Did you use Windows Vista after releasing?
Yeah, I did use Windows Vista, but for example, because I wanted to test out the 64-bit operating system, which wasn't available in XP freely, and so I used Vista, but for example, there was that user access control, the UAC settings, that you got that yes-no prompt in your face all the time. And in Vista, there was only two options. Either it's on and it's annoying all the time, and or it's completely off. So you get back to the XP experience that everything is run as admin and you do whatever you want, and so you're not getting that extra layer of protection. So I actually, after some use of the default mode of always on, I just got rid of it and turned it off. And that's why in Windows 7 they actually added another layer, another level, so that you get less prompt in your face, and so the feature actually started to make sense. So Microsoft learned a lot about Windows Vista in Windows 7. You just look at the name. Vista creates expectations.
Yeah.
And what happens when you have expectations? You're going to get disappointed. That's just a human nature. And so Windows 7 has a very simple name. It's 7. It's just a number. It's not some crazy word. So you have low expectations. We have low expectations. You cannot be disappointed.
Okay, why are you talking about Windows? Do you like Linux?
Well, actually, recently I have to use Linux much more than I used to. I actually didn't used to use Linux at all, but now I'm using it from time to time, not just for .NET Core stuff, but for other stuff that exists only on Linux in some cases.
For example?
For example, I'm using machine learning models using something called DeepStream SDK, which is from NVIDIA. And that SDK only works on Linux, so it doesn't work on Linux. And that's kind of, I actually was pretty surprised about that, but it is what it is, and NVIDIA, as far as I know, are not planning to port it to Windows. And so I started using it, and well, I still like Windows more, but I do see the appeal in Linux. I see some stuff that I wish we had maybe more openly in Windows. And I guess eventually in this new world, if you want to really be kind of know how to get around, you have to know Windows and Linux in a good way.
Yeah, it's a good point. You mentioned machine learning, deep learning, yes?
Yeah.
What do you think about applying this machine learning approach to our regular .NET stuff and sometimes enforcing .NET developers to machine learning?
Well, I think it's like Jeff Procyse said in his session yesterday. It's kind of a revolution. Currently, we're not used to adding machine learning stuff to our .NET applications because we're really used to those algorithms which are kind of do this and then do that, and then like normal algorithms you learn everywhere.
Yeah.
And machine learning is completely different. Nobody knows exactly how it works. Just in some magical way it works. And requires training and stuff like that, which we are simply not used to. But I think it's inevitable, and eventually this will make a difference if you have two applications which are very similar in terms of functionality. Then that added value of machine learning and stuff that makes the user happier and make the program seem more intelligent can make the difference between one application and another. So I think eventually we'll just do that without even thinking that it's weird, even though it is right now.
According to some rumors from guys from machine learning community, they have some negative vision to the future. I know some guys who say ML engineers can be thrown away in the future because you have ML, auto ML, and some general algorithms like using decision forest and so on. So what do you think? Okay, I am not an ML expert. I'm not an ML engineer. So does it mean that I can use AutoML from ML.NET or any AutoML tool, or this regular approach like decision forest and just use it automatically without trying to understand how it works?
Well, I'm definitely not a machine learning expert, far from it. But I think it is something that will eventually turn into like normal algorithms. You have a library, you plug it in, you call some methods, and it does what you need it to do, and that's it. So you won't have to actually think about how it is trained. You're going to get a pre-built model already, and you're just going to call a method that will do all the actual running of neural network or whatever is in there. I believe, that would be the case, and maybe there will be less demand for PhD ML people. I don't know, I have no idea, but I think there's always going to be the next level of machine learning. Do it faster, train faster. Maybe unsupervised learning used more than supervised learning, because that would not require any learning at all. So it could be faster potentially, but it can't really solve today's problem that are solved with supervised learning. So maybe that's something that will be developed in the future. Who knows?
Yeah, and so we just at this moment we have just a small holobar about mathematics and programming, and at this moment machine learning. Why I have asking questions about machine learning, because it's easy to have a talk with machine learning experts, guys who spend 100% of their life working with in this section of engineering, data science, and so on. But for us, for our listeners, I think it's more important to listen to a little bit more practical guys. And if you say correctly, you consider yourself as a more practical.
Yeah, definitely. I'm not actually the one working on the actual algorithms.
Yeah.
So I'm taking existing algorithms and trying to use them for solving real-world problems. This is what we are supposed to do. We're software engineers. We're not data scientists. We don't have these PhD crazies. I'm not working with TensorFlow all day. In fact, I'm allergic to Python. But regardless, we are the ones that take the theory and put it into practice.
And what helps you make a decision what algorithm can you use? Because when we're talking about deep learning, it's a kind of art, making some pipeline between reducers, how to avoid extra learning neural network and so on. And if I understand correctly, okay, some guy said me it's an art. I can feel it. I feel that I don't know, this neural network with this deep is enough. Come on, it's really hard.
In a sense, yes. That's because we don't really have proper algorithms for that. So it's just something sort of happens in there, some magic inside the network, and you just get good results. So there's really no way to predict that, so it's a lot of trial and error and stuff like that, and it is, in that sense, it is very close to an art, and so that's why people like us, which don't do that every day, we'll be working with people that do, and they say, hey, man, we found this algorithm, and this is the proper constants to use to get the best training, because they have some feeling or intuition, if that's even possible, but hey, this is currently this is the way it works in machine learning. That's why many people, I think, find it very weird and look, I don't understand that. So how can I use something I don't understand? It's very, very difficult. For us programmers, we know that if the machine is doing A, B, and C, and D, then we can understand that. But in this case, you can't do that. You just can't understand it. You have to sort of have a leap of faith and say, okay, I have no idea how that works. But it works, and I'll just use it because it gives me the results that I need.
Let's be honest. There are a lot of developers who doesn't know how razorby works.
Yeah, but these things can be. You can actually complete that. You can read about how stuff works because there's documentation, there are blog posts, you have sometimes source code. So it is possible to understand because everything is eventually algorithmic in the classic sense. You can just put some kind of flowchart that you can envision for whatever algorithm you would normally encounter. But machine learning is different, and so this is where you kind of say, well, I have no idea what to do with that. And so you still have to learn how operating system works and how your core CLR works and how .NET framework works, or whatever thing you're actually working with. You have to know that, otherwise you're shooting in the dark and your code is going to be bad, it's not going to be maintainable and stuff like that, and many developers already understand that. But machine learning, well, it's sort of a black box right now for us at least.
I suppose this is good.
There's something good in that because it's not our domain. It's really not possible to control everything, so that's why we have these data scientists.
We can trust it.
There's one thing that I wanted to discuss, and maybe, okay, if you don't want to have a talk about it, but just say me, it's WPF. Because WPF, because .NET Core 3 released with WPF uniforms, but WPF, okay, and maybe you know what happens with WPF. I would say 8 years ago. I mean, why Microsoft stopped developing WPF?
Well, I have to guess it's a combination of several things. The most important one, I think, is the evolution of the client-side web. So once you have the ability to do single-page applications, all that stuff that looks almost like a desktop application and can run on any browser and operating system, don't have to install anything, so there's a lot of appeal in that. And so this is why desktop applications in general were declining in recent years, and I think this is still the state today. And additionally, Microsoft didn't want to evolve .NET framework a lot anyway. So we see that since .NET 4.5, the increments of updates and upgrades are really small, and with WPF they're even smaller. And so this is Microsoft always claims about compatibility and all that, and this is one of the reasons we have .NET Core. And now, when WPF is part of .NET Core, it is possible to evolve that much faster, and it's also open source, so the community can also evolve it faster. And so I hope it will continue to evolve now in a greater pace, and maybe even, who knows, ported to Linux and Mac OS. Because there's a project called Avalonia, for instance.
Yeah.
The original WPF codename was Avalon, that tries to create WPF-like a system that is cross-platform, and it kind of works, at least to some extent. It's sort of in a beta state. But so if someone in the community can do that, Microsoft can definitely do that. It's just a matter of whether they will actually want to do that, and I hope they will.
Actually, there's a joke in our community that when Nikita finished developing Avalonia, after completing Avalonia, we'll get everything. We'll be happy. And you mentioned web, and when we're talking about WPF web, we can remind Silverlight, and I had an experience working with a project with WPF and Silverlight, and from my point of view, that was pretty good. I mean, the idea of Silverlight and the kind of implementation works fine. What do you think? Why Silverlight has died so fast?
Well, it's I like Silverlight a lot as well. I use that, and I thought, well, that is kind of a perfect solution for your applications, because it's so easy to write, very similar to WPF. You have C#, you have data binding, you have all this great stuff and great experience with Visual Studio. I think eventually what killed that is the decline of Flash. So the idea of having a plugin in the browser, that was sort of bad because of all the bugs Flash had and the security holes and stuff like that. And so eventually people weren't really happy about installing various plugins. And at the same time, HTML5 came along that gave some new capabilities that weren't possible to do before that. Even a simple thing like playing an audio or video file, you could do that now in HTML5. You don't really need any plugin. And so sort of the community or the world just decided, well, plugins are not worth it. And so Silverlight was sort of doomed at some point. And I'm really sorry about that. I really loved Silverlight. But it's still supported until the year 2021 or something like that. So you can still use it.
I know a company that uses it. And it's,
I know a few companies that actually had to migrate all their Silverlight code to JavaScript HTML5. Otherwise, they couldn't just, the clients, customers just wouldn't want to install the application, which it's a big pain. But I guess that's life.
To be honest, about Silverlight, there is a question that I didn't find an answer. Why Microsoft didn't add
Silverlight as a part of default Windows installation. Because I remember in Windows XP there were Silverlight updates that required checking it explicitly. I had to check it explicitly to install to my machine. Of course, I didn't do it because I didn't know at the beginning of using Windows XP Service Pack 2. I suppose I didn't know what's Silverlight, and that's why I didn't install it. So the question is why? It's so easy. If you install Silverlight as a part of Windows XP, the most popular operation system, you can. They would, if they turned it on, they would, avoid this problem with requiring users to downloading this plugin system and so on, because operation system would contain it. Definitely.
That's a good question. Unfortunately, I'm not sure I have a very good answer. Certainly not something that I know for sure. I would guess that enterprises, for example, IT admins don't really like installing extra stuff. And if you have a plugin that is updated fairly frequently, IT admins will not do it. So they will refrain from updating, and so this could be even worse. Maybe giving the control to the user is better, but I really don't know for sure.
Yeah. So, okay, because to be honest, from my point of view, there was some politics because the ex-executive of Windows department, as far as I know, has been fired.
You mean Terry Myerson?
Yes, as far as
he wasn't fired. He just left the company, and Windows went under the Azure division.
Yeah.
Which is saying something that really what's important for Microsoft is mostly Azure. And Windows is just one part of it, but definitely not a necessary part. Many machines today are running Linux on Azure, so Microsoft really, I think, doesn't really care as long as stuff is running on Azure. And so this may be a sign that Windows is not as important as it used to be, and that's for sure. But I think that Terry Myerson just wanted to do stuff in his life.
Yeah, the thing is that I thought I just read some rumors that he didn't like .NET approach. He fond of COM, and as a result, he didn't allow Silverlight, making the essential part of Windows XP.
I have no idea.
Rumors
are very easy to spread and come up with, but I really don't know because I wasn't there.
Yeah, and as for Azure, it's an interesting thing that if I understand correctly, if we compare Azure with AWS, Azure contains a lot of machine learning tools. Have you managed to use it?
Not in production yet. Just kind of playing with some of them. I didn't get a lot of chance to work on Azure in recent years, but I may start doing that again in relation to IoT, perhaps. We'll see. But definitely Azure is always going forward in a crazy pace. I mean, I remember the days when there was just a web role and worker role and the queue and the blob and that's it, and then you knew everything in just you can learn that in a day or two and you're done. I remember giving a session on that and I thought, I know Azure. But today there are so many services, so many options that it's really difficult to find your way around, especially if you're starting out, you want to do something, should I go with an app service, maybe a logic app, maybe something else, so how do I combine them? And I think this is something Microsoft needs to emphasize, some good guidance of where to start for given scenarios. So what are the actual differences in the various services? How do you configure that? And even for a single service, there's so many options, and debugging is still a pain in many scenarios, as I found out. So there's still work to be done there, but the pace is really crazy.
On the other hand, this level of complexity allows certain architects having such a good salary because you just come on, let's pass AWS or Azure Solution Architect exam, learn all these services, and if your customer say, okay, I need this blah 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 blah, you say, come on, you can use this service, and perfect.
Yeah, I guess there's always that side of the story. For every feature, there always come those experts, and sure, I mean, Microsoft and other big companies provide us work indirectly, and so this is just, I guess, another facet of it.
Yeah. So, and anyway, do you like this new modern cloud world? Because when we are talking about the old world with that were close to hardware, that you had to buy machines, physical machines, taking care for it. It's a life with pets, not kettles.
Well, I think it's inevitable. I mean, I still like my machine. I like to buy a powerful machine and have control over what's going on in my machine. But eventually, for some things, you just have to have something like the cloud. You don't really want to manage servers and stuff like that. Maybe some people like it, but it's not productive. And I think the cloud is definitely inevitable and continue to be so for many years. Even though I still enjoy mostly writing desktop applications on my machine and not something in the cloud which I can't see and really not that easy to control. I don't need to pay for my physical machine in terms of CPU and stuff like that. But hey, there's the real world, and there's things that you like, and they're not always aligning as you would like.
And so, what do you use while developing desktop applications today?
So what?
You say you're fond of writing desktop applications.
Yeah.
Do you use WPF or?
So I used to use a lot of WPF in recent years. Nowadays I'm back in C++ because
back in C++.
Yeah, so I'm back using more C++ than WPF for my desktop applications. Because of performance issues, WPF has some still, the controls are not as fast as native controls, and some of my applications require that. So in that case, I'm going back to Windows template library and C++ and all that stuff. And some of it is really good because you get an executable which is like less than 1 megabyte in size and no dependencies except the Windows normal DLLs. With .NET you get like a million gazillion of DLLs and many dependencies, and sometimes it's really kind of annoying in a way. But I think WPF, if it could be better, I would happily go back to working with WPF for all my desktop tasks.
Actually, when we are talking about C# and C++, I know I like talking with guys who use C# and C++ in the same thing because to be honest, I don't use C++. And I remember some holy war with my friend who is a C++ developer in Kaspersky, and he said, "Come on, how it's possible to use this? You have exceptions and GC, it's so weird." If we're talking about modern C++ that are very complex, and modern C# that are, to be honest, very complex too, especially for young developers, what do you think? What do you think about it?
Well, modern C++ can actually be simpler than classic C++. Unfortunately for C++, the problem is you can't take any features out, really. So you have to just bring new features in. And so if I'm thinking about a new developer say, hey, I want to learn C++, I think that developer is doomed. And so it's very, very difficult to get started because there are so many paradigms that have been built for many years, and now there are new paradigms in modern C++, starting with C++ 11, and so it's very difficult to understand how to start, how to get into this world, especially when you have so many other very productive languages, just as like C# and Python and Java, and all that stuff. You can do a lot of things in less time, and it is still easier, even though C# is in the version 8 and there are a lot of features and all these things, and it starts getting more complex really. So for new developers as well, still the learning curve is much easier and much quicker in C# than C++. And I think what we're seeing in recent years, the number of developers in C++ is not growing. It's not being reduced as well. So it's kind of a constant. So I think this means that people are getting a hard time getting into C++ or just don't want to do that. Because there are so other pretty good alternatives for many types of applications.
Or they have a good health.
Maybe. So I think in C++ is really geared towards very specific scenarios where really you need to have as much control as you can. But for other scenarios, there's really no good reason to use C++, and that's why C# and Java actually replaced C++ in many of the applications in the 90s. So C++ was declining, and C++ 11 gave it a good push forward, but still, productivity is still not as good as other languages. So I think C++ is in some kind of trouble, and that's why new languages have reasons such as Rust, which aim to replace C++. So there's no garbage collection and stuff like that, but the language is better in many regards. And I mean, it is what it is, and C++ cannot sort of remove its C heritage or remove not very good features. It just can't do that for compatibility reasons. And so it's kind of a catch-22 thing. Mm-hmm. And talking about C# is still much easier to learn, and it is evolving as well. So it's not as simple as it used to be. Yes.
And I just want to make a small note about these languages like C++ and C# from desktop development point of view, because if we can notice that there are only two technology approach, technology stacks that are focused to UI development that don't use garbage collection. It's Swift, Objective-C, and Qt with C++. All other popular front ends, it doesn't matter, desktop or web or mobile technology stacks contains GC, and it's not exactly good for UX from UX perspective. I mean, if your desktop application has been developed with GC, it means that your UI can be smooth enough. Can be, I mean, you will experience some problems with Stop the World. How is it possible to have how it happens in our life?
So I guess it's something that definitely can happen, but UI is tricky in many respects. I actually been thinking about that a lot recently. How to find the perfect library for doing UI.
Yes, Qt.
And I couldn't find even Qt. I don't like some of the stuff there, and it's not completely free, so it's kind of an inhibitor for me. But GCs definitely can be a problem in some cases. But if the UI framework is good, then it can reduce allocations in critical path. And if you don't have allocations, you don't have GC problems. And so I'm not sure GC is the real problem. I think there are other things beneath the surface that are problematic in terms of how you actually draw the UI, how do you use the system and resources properly. And so for WPF, for instance, one of the reasons that I stopped using that for some of my applications is that I don't have a good data grid. And default data grid in WPF is really bad, but I even use third parties, and even third parties which are much better than the default WPF data grid is still not good enough for some scenarios, still not fast enough, still stuff is going on there. Some of it maybe because of garbage collection, some of it because of just the complexity of WPF. There are styles in place and templates and stuff like that, and all this takes time. And in some cases it's just too much. So a lot of thinking has to go in there, and there are a lot of there are some interesting libraries out there, such as IMGUI or Dear IMGUI, which is something called the immediate mode GUI. So you actually, what we usually think of GUI is called retained mode. So you say, here's a button, I want the button to be here, and the list to be here, and so on, and someone actually takes care of making it just there. But in immediate mode GUI, you actually draw it, sort of, you say, okay, now I'm drawing the button, if it's clicked, I want to do something, and you sort of build the UI yourself in a sense. And that's more efficient, although a bit weird. And Dear IMGUI is a very well-known library in that regard. It started as C++ library, but there are many bindings, including .NET. And it works much better because it's not doing stuff that doesn't need to be done. So for example, if the list is hidden, it doesn't draw anything. So you don't actually have to waste time with layout and stuff like that. There's no, it's much sort of smoother experience. But I'm still looking for the perfect GUI library.
I hope you will find it, and it will not be a JavaScript library.
No, JavaScript is off the table.
Okay, unfortunately it seems that we are running out of time. Thank you. That was very interesting, very fun. As for me, to be honest, I thought we would talk only about .NET Internals. I prepared a lot of questions, but gladly we have a really fun, interesting discussion.
Thank you very much.
Yeah, thank you. Have a nice day.
Thank you.
Hello, and the last but not the least, in our super studio, I'm not sure about super studio, this man, Scott Wlaschin. And another man of F sharp. Come on. Guys, I think my experience is F sharp is not enough. That's why I took one man who is very well known from F sharp perspective. It's Roman Nevolin, and if I took
and another man who known about functional programming in the whole world. I think one of the most known speakers about functional programming. I'm pretty sure about it. So Scott Wlaschin. I think any person who anytime checked anything about functional programming knows your site, your book is brilliant. Again, anyone said it, and that's my time to say the same person. So yeah.
Okay, guys, and I want to ask one question. But you really need this F sharp. Come on. So something functional.
C sharp is fine. Who needs F sharp? Exactly.
Yeah, who needs F sharp?
Absolutely. So that's a very good question. I think when you start to, I think first there's a lot of things that F sharp. Obviously, in languages, in some sense, we can do anything in any language, and they're all the same. But there's a reason why certain languages are better than other languages for certain things. And I think if you're doing sort of functional first programming, where everything's a function, and you just treat, functions are your main way of doing things, then I think F sharp is better. But even if you're not doing 100% functional programming, there's a lot of nice things that F sharp has. One of them is that the defaults are different. So, for example, in F sharp, things can't be null. And if you want things to be null, you have to make an effort In C#, it's the other way around. Things are, normally null by default, and you have to make an effort to make them non-null. And in F#, everything is immutable by default, and if you want it to be mutable, you have to make it an effort. And in C#, everything is mutable, so the defaults are very different. So just from that point of view, there's a lot of nice things about F#. And finally, one of the really, really nice things about F# is what we call the algebraic type system, or the composable type system, where you can use types as a building block for domain modeling. And even again, nothing to do with functional programming, just be able to compose lots of small types to make really big types and fit the whole thing on one screen and have it readable by non-technical people is a really fantastic thing. And people might know that I actually have a book all about this topic, so if you're interested, that's called Domain Modeling Made Function. I'm just going to put a plug in that for that. But I think people who've tried that, again, not even the functional programming side of things, but just trying to express a domain model in using the type system is a really nice way of doing things. And I found in my experience when I'm actually doing domain modeling for people, using that has been very helpful, and the people I'm working with think it's very good. And I think you have a Roman here an opinion.
I have another question. I mean,
well,
it's all good what you said. It's nice, and it's really easy to compare between C# and F#. But what about some different comparison? Do you familiar at least a bit with Kotlin? What about comparison between F# and Kotlin? Because, for example, Kotlin have the same composed type system, the same thing about
I think
options.
Kotlin's very nice, and if I was on the JVM, I would probably use Kotlin as my favorite language instead of... I mean, Scala has a lot of powerful things, maybe too much powerful things in Scala. And Scala, there's many, many different ways of doing something.
Scala makes you to write exactly.
Yeah.
In Scala, you have to write in Scala way or...
Yeah, I mean, you can do very object-oriented Scala, and you can do very functional, even more functional than Haskell style Scala. And if you put them both together in the same code base, it makes it really, really hard to maintain. So I like languages which are opinionated, or at least have there's a standard way of doing things. Mm-hmm. And, Python is one of those languages, and I think Kotlin is one of the languages, and I think F#. So yeah, I think Kotlin is very, very nice. And like I say, if I was on the JVM, I would definitely be using Kotlin, but I'm a .NET programmer, so I use F#. I think F# is a bit more functional than Kotlin in terms of it has more functional features. It's got... Without going into too much functional stuff, I think it is definitely more functional. But Kotlin is a very, very nice language. And,
Okay. Yeah. Anyway, my opinion on the previous question is just some tricky question to ask, because this comparison is much more interesting for me still. My opinion is that F# is a good language for very senior level team. So C# or Java was languages originally designed to write code in some specific style to make you less chance to make a mistake, like most of general purpose languages. F# gives you pretty much possibilities, but more possibilities you have, more chances to make an error you have.
So I actually disagree with that, because I actually have a blog post on this called Why F# is the Best Enterprise Language. And that's because I think F# I think is actually a good language for junior developers, because there's less things that go wrong. As if you are learning, for example, the mutability and the non-null stuff, all that stuff is great. If you have a big code base that's maintained by lots and lots of different people, that's the kind of stuff you want in the code base so that people can't mess it up easily. So I think in a funny sort of way, C#, there's many, many different ways of doing things in C#. Like there's 4 different ways of doing async, for example. And in F# there's only one way of doing it. So I think when you have a big code base and you have lots of different people of different skill levels, I think that's good. Now, I mean, one of the things about F# is you can't do really, really weird functional programming stuff like you can in Haskell or Scala. And so that stops. It means there's a kind of upper bound. You can't make it too weird. You can't really write very, very weird F# code. I think which is a good thing.
It sounds good, and can I agree? And I can agree here theoretically. Do you often work with junior developers?
I have trained people. So it's interesting. I just did a recent thing where I was training people in F#, and these are people who were a mixture. There are C# people. There's a .NET.
But it was mostly middle level people.
So the people who found it easier were the junior people.
Oh, okay.
The people who have found it harder were the senior people. If you've done C# for a long, long time, it's very hard to change the way you think. But if you've only been doing C# for 6 months or a year, it's actually easier to change the way you think about programming. And you might say, it's obvious that things should be immutable. It's obvious that, So I don't know. I'm not sure. I'm not convinced that it's harder for people. I don't know. It'd be an interesting thing to talk about.
You're talking about immutability or something like this, but you can make something mutable in F#, right? And the junior level people pretty often doing such a thing like, I want to do it this way, so I will do it whatever it costs. I want to have something mutable, okay, it will be mutable. I will make it mutable.
I mean, you still have to do code reviews, but I mean, I would say the same thing as for senior people, because if you're used to doing things in a certain way, I mean, it's really, if you're used to doing things in a certain way, you want to keep doing things the same way, because that's what you're used to.
From my point of view, senior people should be flexible. If you're thinking in some way and you're not trying to think, can I do it some other way or not, it's not a good thing for a senior developer.
Okay, so it depends what you mean by a senior developer. So some senior developers are people who've just had 15 years doing .NET. Now, they might, if you call them, they might like to do it that way, and they're very happy, they're very experienced with C#, and they can do all sorts of amazing things with C#, and they don't really want to learn another way to do things. And that's fine. I mean, that's fine. But I mean, junior people tend to be more interested in learning new things. It depends. I mean,
it's much easier to learn.
I'm a pretty old developer. I've learned lots and lots of different programming languages, but I like to learn new things. But I guess some people, they don't. They're quite happy. They learn a certain way of doing things, and they're quite happy to do that way. And once they're happy with it, they don't feel the need to change. So I think it depends on the kind of person you are.
Pretty right.
So I don't. The only one of the interesting things about programming is we have no evidence for any of this stuff. We can argue about this, and we can say, well, I think I'm right and you think you're right, but we don't have any proof. We just have stories, and which is kind of sad, really. It'd be nice if Microsoft or Google or somebody would do some science and see if these things were true. But there we go. That's where we are right now. So we can have my stories versus your stories, and
that's a pretty common thing, because people in programming pretty often expect you to, I don't know, and they're asking you a question like, what is the right way to do such a thing, this way or this way? And the right answer is usually no. There is no right way.
That's right.
There's a number of ways you can choose any. There's different consequences, different results, but still, both ways works. All the ways works. And even like this common question, I don't know, what is better, functional programming or object-oriented? There is no answer. And you shouldn't, from my point of view, you shouldn't even write something in completely functional or completely object-oriented style, because you have a number of small decisions. If you're taking one big decision and use it all the time, probably it's
exactly. And that's one of the things I really like about F# in particular is it's very pragmatic. You can change if you need to do object-oriented stuff, or you need to be, compatible with existing C# code. Something it's very easy to do that. And I think that's really nice.
I used to write Haskell, for example, but Haskell is much less flexible for me.
No, you have to do it in a certain way. Absolutely. I mean, and it's interesting because I have a lot of background in OO. I used to do a lot of Smalltalk, which is about as OO as you can get. So I don't hate OO. When I did my website, it's really about me learning functional programming and sharing it with other people. But I don't. The idea that somebody's right and somebody else is wrong, I think that's not it's not very helpful to people. It's nice. Here's the pros and cons of each approach. Which one is the best one to use? What's the right tool for the job?
You mentioned Scala, and according to the last news from Scala, they are developing huge redesign .t.
Yes, that's right.
From my point of view,
Scala 3.
And from my point of view, this is great, because every language with a long history contains legacy and contains wrong decisions. So, what do you think in terms of C# and F#? If you could create a .t for F# 40, what would you do?
Well, that's very interesting. I mean, I think talk about legacy. I mean, C# is interesting because there's been like 4 generations. There was the original version which didn't have generics, and then there was the early generics thing, and then there was then they introduced lambdas and all that stuff. So you can have 4 or 5 different styles in C#, and I think one of the you get a lot of old history in a language, and it's very, very hard to avoid that as a language gets older. So sometimes it is tempting to throw all that away. But if you look at Python 3 versus Python 2, you have the same situation. We'll have Scala 3 or Dotty versus Scala 2 is going to be interesting. I don't know what's going to happen there. F# has actually had quite a few changes. It's been around officially for just over 10 years now. But because not that many people have been using it, there's it's okay to we haven't got a lot of legacy code that we have to keep supporting. Although it actually is backward compatible with original F# code, which is kind of nice. I mean, that's the Microsoft way, I think there's a few things that if Don Syme and the F# team were doing it today, they would probably do it slightly differently. But overall, it's pretty good. I mean, it's a pretty clean language. I think their philosophy is to avoid adding new features. There's a lot of people who complain that F# doesn't have higher-kinded types, and it doesn't have type classes, and it doesn't have and they're very wary about putting that stuff in, and I think for good reason, because I think once it's in, you have to support it forever.
Yes.
And that's just very dangerous, and we can survive without it, and we might see, it might be, for example, that monads go away in 10 years' time. If nobody's using monads anymore, they're using something else, effects systems or something. Who knows? I don't know. But I mean, these decisions, if you make a decision and you build it into the language, it's really hard to change it later on.
For example, sometimes I feel like languages adding some features is some kind of marketing. For example, I feel like last changes in C# are some kind of marketing. Not really the bad or something like this, but the features are already now, like pattern matching in a C# way. It's some kind of marketing. It's not really what pretty much people in C# community needs or something like this, but it looks cool.
Well, I think it's been driven by the advanced developers. It's like, well, they learn other languages which have pattern matching and they have immutability, and it's like, and the language designers themselves, the C# people, they are very well aware of other languages, and it's like, well, this other language has a cool thing, maybe we should put it in C#.
So, but still, it's some kind of marketing. When you just sell in the language, you want to sell this language, you want to sell it compared to other languages.
I don't know they have to sell it to anybody. That's a good question. Do they have to sell C#? I mean, most people are going to be using C#.
I mean, if you're doing something, especially if in a big company, you want to as much people as possible to use it.
I think you're selling it to developers. You're making it cool. I mean, developers are very aware of what's cool, and is it a cool language or not a cool? And like COBOL is not a cool language.
I mean, it's so bruising because anyway, developers like new toys.
Yes.
When you work in some languages for 10 years, it's a bit boring to do the same things. You want to
learn some new things. Right. Yeah. So that's true. I mean, and I can understand, all the things they're putting in C# are all good things, but it does mean that it ends, if you do have to be careful, you start having more and more features, and they all have to be maintained forever. And I don't know.
Starting from the last versions, I feel like it's a bit of feature overload.
Yeah.
Because it happens that we have too much features, and it's more and more and more. And I feel like, 3 versions more with the same.
I feel a little bit. I would feel that if you really want to do functional programming, don't just add a bunch of functional things to C#. Just switch to F#, because they're compatible with each other. But that's just then goes against the grain. People like to add new features all the time. As programmers, we're pretty bad that way.
There's people in Microsoft who like to design new features. There's people who use in C# who like to use new features. So they're just working for each other. But still, I think there will be some kind of entropy because it's a not good thing for language in longitude.
Yes.
But in case nothing changes, language won't have an entropy in case of just, there's too much features adding and it's too hard to understand, too hard to maintain any trains. No, it won't happen anytime if you're not adding anything new. But there's another kind of entropy. It just won't be a popular language, like COBOL.
Right, but COBOL is not trendy, but it's still really popular. Most people's paychecks are probably coming through a COBOL system. I think we should have to be very careful about knocking old languages. I'm sure, COBOL seems like a nice language. It's just not a cool language. But Java, at one point Java was super trendy. It was very trendy. Everyone wanted to do Java. And now Java is not a cool language anymore.
But it's still much more popular
but it's
than
still
C#.
very popular. Java, I think again, it's just, I don't know, Java is probably popular than C#. I don't know how much more. C# is pretty popular too, but
enough. I mean,
it's they've got the platform. Once you've got a lot of legacy code written in a system, it's very hard to change.
But also Java is an example of language who starts to ruin because of pretty much new features because of adding legacy. So original idea of Java was, I think there was this Java manifesto or something like this, like 5 principles of Java, and first was Java is a simple object-oriented language. And nothing of this is true now, because Java is not just object-oriented, it's not simple.
No, exactly. No, I know, exactly.
It's not a language.
In some kind of way.
Yeah, I mean, again, the JVM, I don't think it was designed originally to have a lot of other, unlike .NET, which sort of was designed to be a multi-language platform. I don't think Java really
It's much more young. It's younger.
But I mean, Java now, the JVM is a multi-language platform now, which is kind of nice. But it's interesting. I don't know. Again, there's no easy answer. If I was a language designer, or if I was trying to pick a new language for a project, I mean, if I was picking a new language for a brand new project, I would probably pick F#, just because, as you say, it's a cool language, and I would attract a lot of cool developers. And I probably wouldn't pick COBOL for a new project, because I wouldn't, I wouldn't get a lot of cool developers working on it.
Because we are still people, because software developed by people, not the machines. And people like to do interesting things, not just to develop software. It's not interesting for me every day. I don't want to spend my time for money. It's interesting, but still, I mean...
But it's interesting. So, I've learned lots and lots of programming languages, and I think that's interesting. But what's interesting to me now, as I'm older, is actually learning new domains, because it's about the problem solving, and the language is sort of not the most important thing. So if you said, here's a project and it's in PHP, which is not my favorite language, but it was a really interesting project and it was really interesting problems, and I might say, okay, I'll give it a go.
Also, I used to work with pretty much different languages, that happened, and nowadays I found out that in any language I can find good, I don't know, maybe libraries, maybe something like this, good wrapping and write in my own style I like.
Yes.
And that's enough.
I mean, for JavaScript, for example, you can do very, very functional JavaScript.
It's very specific language, but there's too big and some places good ecosystem that you can write in any style in most cases. There's plenty of very different JavaScript. I don't know, JavaScript of jQuery age and JavaScript of React. It's two different JavaScripts completely.
They're very because it's not really the language; it's the libraries and the approach. I mean, that's the thing. The languages, I think, is actually very overrated. I think it's the libraries that go around the language. So you can write, and Scala is a good example. It's the same language, but two completely different ways of doing it.
I know one funny example for language, which looks the same in most projects, which is the same patterns, ideas, and so on. It's C#. Because C# is a language we're using .NET platform for most of things. So using .NET libraries for web applications, Microsoft libraries for CRM, and so on. And you're using mostly language features, not some libraries.
I don't know. I mean, people don't use web forms anymore. They use MVC. And then now MVC is sort of going away and being replaced with whatever,
Updating MVC is kind of updating .NET, kind of updating language.
But I mean, web forms and MVC are completely different ways of doing stuff.
But it's like updated language. They're not using, I don't know, in Java people don't use some old APIs in Java.
No.
And it's still an update in Java itself.
But you may have to maintain, I mean, then you have an old piece of code and you have to maintain 5 different approaches. You have all these different libraries and all these different frameworks, and they all have to be maintained forever. And
still, it's a funny comparison, because, for example, in Java, most companies using Spring, which is not related to JVM Java. It's just completely different library, completely different principles. It's AOP and so on. So it's a different thing. And in .NET, most of companies, people still using Microsoft instruments. It's a kind of .NET platform.
You have the ecosystem, and if you know how to do. If you know the .NET ecosystem, then yes, you know how to deploy it, and you know how to monitor it, and you know how to debug it, and all these kinds of things. So there's definitely a lot of knowledge associated with a particular platform, and I think again that's why one of the reasons I like F# is because it is really compatible with the .NET platform. So if you already know C# and you're already familiar with all this stuff, you don't have to learn a whole bunch of new libraries and a whole bunch of new. Like with Haskell, you have to learn a whole bunch of, a whole library manager and a whole deployment technique and all this stuff. There's a whole different way of doing things. The nice thing about F# is you can use what you already know, and so that's a big plus, I think.
Yeah, I think F# is one of the most practical languages you can learn new. So, for example, Haskell is very interesting to learn.
Yes.
And you just said why. You should learn whole new world.
Exactly.
It's completely different.
Yes.
But if you're a practical engineer and you want to learn some language, you personally want to, I don't know, solve some small problems or write even in enterprise solutions, anything, F# is one of the best languages from my point of view, just practical.
Yeah, exactly. And because one of the things is you can use all the libraries, all the .NET libraries. So, for example, if I'm running on Azure or running on AWS, I can use the SDK that's already been written for C# and I can just call it from F#. Or if I'm using SQL Server or Oracle or whatever, I can use the drivers that are already there. So I don't have to reinvent the wheel. Pretty much any big system is going to have a .NET compatible API.
That's the reason why I compared it to Kotlin, because Kotlin is kind of doing the same thing.
Yeah. I think Kotlin and F# are very similar in terms of the JVM version versus the
exactly.
Yeah.
Actually, when we're talking about practical languages, I would say F# has a serious issue with tooling. What do you use for tooling?
Yes.
Maybe you can suggest some tips.
Well, yes and no. I think the thing is that C# has excellent tooling, and so if you're coming from C# and you go to F#, there are some things that you can't do, and people feel like it's a downgrade. But if you compare it with other functional languages like Haskell or something, the F# has fantastic tooling. So the thing about the F# and Visual Studio has very, very good support for F#, and VS Code with the INI plugin has very good support for F#, and then JetBrains Rider has very good support for F#. So most of the platforms that people are doing C# in, they already, if you use C# in Visual Studio, you can use F# in Visual Studio without
especially now. 4 years ago, it was kind of harder.
It's now, and they've done a lot of work. The F# team has done a lot of work to support it in Visual Studio.
And INI team.
And the INI team, which is the plugin for VS Code, is very, very good. And they're getting better and better. I mean, they're not 100% perfect, but the tooling, I wouldn't say the tooling is bad. If you're used to ReSharp or something, there's a lot of stuff that in C# you can do this, and in F# you can't do it. But funny enough, I don't miss that, because most of the things I don't feel that I even need to do. Like, for example, refactoring methods or something is really important, that kind of thing to do in C#, but in F# you just copy and paste, because functions aren't attached to classes, so it's really easy to paste them, copy from one module to another. So that kind of thing, a lot of the problems don't even exist because it's not that big a deal. So, yeah, I mean, it's true, the tooling is not as good, but to be honest, I have not missed things like ReSharp at all when I'm doing F#.
I can describe it as enough.
It's certainly good enough to be productive. It's not going to stop you being productive. Yeah.
Exactly.
You think that you've got things like autocomplete and very nice error messages and all that stuff, so that's all good.
Actually, it's very cool. And yesterday we had just a small talk with Raffaele Rialdi, and he mentioned an interesting approach, because he's fond of code generation.
Yes.
And he said, what's the best code generation tools for in .NET world? For example, it's Wlaschin. F# doesn't support Wlaschin.
Yeah.
And as a result, if code generation suits my requirements, suits me to solve this problem, I can't use F#.
So it depends. The nice thing is that if you can generate C# code, you can put it in a C# assembly and use it from F#. So you don't have to. You can't mix C# and F# code in the same project, but you can certainly mix C# code and F# as different assemblies and call them from each other, and that's typically it's pretty easy. So yeah, if you need a code generator, generate C#.
And some code generation tasks solved by type providers.
Yeah, and you can use type providers in F#, which are the things that they generate code on the fly at compile time.
So
it's kind of similar. They're similar to kind of. It's kind of hard. It's kind of hard to write a type provider.
Not really, honestly. Not really, honestly.
No,
I don't know. I mean, I've done a talk in one of previous .next about creating no type providers, and from my point of view, if you run it for simple task and if you understand the approach, I mean, you spend 1 hour looking on talk something like this, it's solvable.
It's very useful, and it's always writing a generic piece of code that's reusable is always harder anyway. But yeah, you could certainly, you could write a generator or you could write a type provider either way. The nice thing about type providers is they happen at compile time, so you get compile time errors straight away. Like, for example, if the database type provider, if the database schema changes, you'll start getting compile errors in your code. Or if you're using the XML type provider or the JSON type provider and you change your JSON, you'll start getting errors straight away, so that's good. You want the errors to show that something's changed and your code needs to change to fix it.
Yeah. It's cool. Actually, my colleague said one interesting phrase. It's a phrase from architect from his the previous job. And the phrase about Scala, according to experience of the architect, Scala developers can be split to two types. Those who understand, what are monads, theory of category, and that guys.
Yes.
What about F#? Okay, do we need to understand what's the difference between monad optional and monad maybe?
Depends.
It just meant, I would say the thing about the F# community is they're very practical, and then things like category theory and all this kind of stuff, most people in F# are just not that into it. Some people are, and it's interesting to learn about, but it's like the F# language can't do a lot of that stuff, so it's interesting to learn about, but you're not going to use it in the code. Now, fortunately or unfortunately, in Scala, you can do that kind of stuff. And so if you learn about it, you can say, let me put in these category theory things in my Scala code. And that's very cool, except the next person who comes along to maintain your Scala code has no idea what you just did. Yeah. So I think it's a bad thing. So I do think, and again, it depends on whether it's code just for yourself or it's code as part of a team, or, you're learning, or whether it's meant to be production code or whatever. If it's code which is part of a team and it's meant to be in production, it has to be maintained over 5 years, I think that kind of stuff is bad. I think it's good to have not simple code, but code that most people can understand. And so I think, I would definitely stay away from category theory, because most people who are coders are not going to know that stuff.
Yeah. So the best thing about F# for me is that you pretty easily can write a code that other team will understand, don't matter what they know or don't know. They don't even have to know some F# things. I don't know, maybe they have to learn a couple of operators, like, that's a pipeline thing, now I know it, now I know how the order is. But it's like couple of hours of work. Maybe for a whole project it can be a week of whole understanding and getting used to all the things, but still it's not a long time at all, and pretty often people just come into F# code, looking on it, I know how it works, thanks.
The talk I'm doing today at the conference today is exactly that. There's couple of different ways of doing composition in F#, which is piping, using bind in computation expressions or whatever, using other kinds of, 3 or 4 different ways of doing things. Yes, you have to learn what they are, but in a couple of weeks you can probably have a pretty good understanding and you can start being productive. And the chances are that you're not going to run into weird stuff that nobody else understands.
Yeah, exactly. And what problem for me in Scala is that Scala pretty often forces you to do very Scalish thing.
Yeah.
So that's my main concern about Scala and other languages.
I think Kotlin, I would choose Kotlin over Scala precisely because you can't do weird stuff in Kotlin.
Exactly.
But again, it depends on what you're doing. If you want to learn functional programming, then learning Haskell is great because you're really forces you to think in a certain way. But if I'm using it for production code or something, then I don't know. I maybe think differently. But certainly for learning for your own fun, it's different. Yeah.
I had one pretty big project in Haskell we've been doing, and at some moment I just felt like I'm doing things just because I have to do things in such a way, not because it's an optimal way.
Right.
Which is pretty bad for any engineer because...
Yes. There's no backdoors in Haskell. There are some backdoors in Haskell, but in genuine, they really, really want you to do things in a certain way.
Yeah. So sometimes you just find yourself doing some things in a functional way, but pretty ugly functional way, just because you have to do it in a functional way. There's no...
Sometimes it's not. It's nice, for example, in F# you can use object-oriented stuff if you want to.
Yeah.
And sometimes that's actually just the right way of doing it.
So actually most of my code is some kind of mix of functional and object-oriented ideas. So from my point of view, for example, your book is some kind of mix of such an ideas too. Ideas, not really a style, but ideas. So domain-driven thing at the beginning was anyway about
Right.
some kind of object-oriented, but it fits functional programming in a good way too.
Yeah, exactly. I mean, and the domain-driven design thing is a whole other way. I mean, really, to me, there's actually much more importance than functional or object-oriented, which is getting everyone on the same page and making sure that everyone understands what you're trying to do. And to me, that's the most important thing of any project. So whichever programming language you use is not that important. Because if you think about it, if you think about the most successful software companies, you know, some of them are using PHP, some of them are using Python, some are using COBOL. You know, it doesn't really, the language you use, I don't think makes that much difference. I think it's the fact is, can you get everyone understanding what you do? Can you, you know, really create value for the customer? So to be honest, I mean, we like to talk about programming languages as developers. We love to talk about this stuff, but in the big picture, I don't think it's that important.
It's still talking about cool new toys. That's the reason why. If you have a cool new toy, you want to talk about it.
It's cool too. We love our toys. And but it's funny because, you know, other people, you don't hear like plumbers talk about, I just got this new kind of wrench that works. Well, maybe some plumbers do.
Or
electricians and stuff. I don't know, maybe they do. But I don't. Maybe they do hang out. I have to go out on electricians or plumbers and find out what they talk about when they talk about the Hacker News. Is there a Hacker News for electricians where they talk about the latest? They share blog posts about. I don't know. I don't think that's because it's a very mature area. And there's probably new gadgets that come along, but it's not quite the same. There's pretty much a standard way of doing things in most disciplines that have been around for a while. I think programming is so new, we still really don't know what works and what doesn't work. We make it up most of the time.
I also think, working with this, people always been discussing something, in most of cases new, but still discussing some approach to solve problem, comparing it to other approach, and as a result of the discussion, it always was like, but there is no real difference, but still, they've always been discussing it, because people just like to discuss things.
It's fun. I could do it. I'm quite happy to debate programming languages and libraries. It's fun to do. Like I say, I'm not sure from the cut, in terms of bang for the buck, in terms of delivering value, I'm not sure how useful it is, but it is certainly a fun thing to do with other programmers.
Yeah, exactly.
It's a great thing, and I don't know, when am I talking about such languages with a very strict type system like F#. I remember Robert Martin and his phrase about Kotlin. That, he said something like, okay, Kotlin is very awful because you have to satisfy a compiler. Guys, let's use Python and write tests.
Right.
He's right? Is he right?
So this whole thing about, I think it depends on the context. But I think for enterprise programming, I think statically typed languages are definitely the way to go, because the compiler can actually can be the test. I think if you're not used to it, you think the types are annoying and they get in the way when you're programming. It's like, the super compiler won't let me put what I want here. And so I'm going to go to Python or Ruby or something. But I think when you get the hang of it, types actually are like a safety belt. They stop you from doing something stupid. And you have a lot of confidence. In F#, I can make a lot of changes to my code. I can do some major refactoring. And then when I try to compile it, I get all these compiler errors. But then when I fix all the compiler errors and eventually all the errors go away, I'm very confident that code works. And that's a really nice feeling. And that is not true for Python. I used to do a lot of Python programming. And just recently I had a job where I did, a bunch of programming, and then I had to change it. And I was very scared to touch anything because I might break it. So,
actually, it's a good point about it. If it compiles, it works. But actually, it doesn't protect us from, for example, changing minus to plus.
It doesn't
make issues.
Let me just give you a simple example.
Yeah.
You have tests, right? Unit tests. And okay, if all your tests works, is it mean that your code works?
No.
Is it a reason to not write tests?
No, because unit tests, there is no
Types is a kind of integrated in language tests, and you just have to decide, do you need these tests, do you need these things to be tested and work this way or not? That's all.
And actually, if I understand Robert Martin correctly, his idea is that sometimes you don't write these tests, but if you have a very strict type system, this test is already written and you should satisfy it. It's like you have automatic system of tests, but you have to satisfy it too, even if you don't need these tests.
It's always a trade-off. So even if you don't need this test, okay, it's easy. You don't use typed language. You can do it still. So, for example, we just discussed something about machine learning with Dmitry Sholshnikov, who is working with this thing, and we discussed why Python used to be more useful than C# here. Because when you're writing some data science script, you used to write it, I don't know, like a one-time thing. You used to write it like it should be run to one time, and then you forgot about it. Yeah. You never maintain it, and so on. When you're not maintaining thing, you don't need, for example, plenty of tests for it. And the same way, you don't really need types here. Because, okay, yeah, the idea is right. It's another thing that you have to spend time for. You're not writing tests here, you write in types. That's some kind of contract you have tests about in typed language. So in case you don't need it, you're using Python and you're okay about it. In case you're doing something you have to maintain, if you maintain anything, the longer you maintain it, the much more you need tests. So typed language is better. For enterprise, you always maintain things and maintain for a long time, and pretty much different people write it, so tests are good.
And also the thing, when you get used to it, I mean, there are people doing machine learning in F# using scripts just like Python, so they're not writing big compiled things. You just write a bit of code, pulls in some data, and you just highlight it and you run it just like Python. And the type system doesn't really get in your way because typically everything is a float and it's a matrix, an array or something. You're not normally going to get a lot of compile time errors anyway. So the compile system, the type system doesn't really get in your way in that case either. And when you get familiar with it, if you see a little error like you're supposed to have an int instead of a float, it's fine, you just fix it. Not a big deal. So I think it's one of the things where people complain about it more. Normally I think the answer is to ask people who've done both. Whenever people have a very strong opinion about something, it's like, I like this kind of food. And they say, but have you tried this other kind of food? No, I never have tried it, but I know I don't like it. And it's like the only way you can get a good opinion is people who've tried both kind of food. And then you can actually ask people, what's better because they've tried both. And I think it's the same thing. If you've tried statically typed languages and you've tried dynamic languages and you have a lot of experience with both, then you can give a good answer. And I would say, yes, sometimes dynamic language is great and sometimes static language is great. And I'm not going to be dogmatic and say you're wrong doing it, And I think sometimes you have to. Some people do like to say, if you don't do it my way, you're wrong. And I just think that's bad.
After any talk, I have this funny thing when I'm talking about functional programming for 14 minutes and so on. And after this talk, there's a questions part. And some person, he was thinking for a talk. And at some moment, he's asking some tricky question about some tricky case when it's never be used. I mean, when functional programming won't be practical and so on. And he's expecting what I will answer. And the answer is, okay, so you don't use it here. Right. Yeah, I mean, I love functional programming, it's great. I love the way the code looks here, it's elegant and so on. I mean, in case you're using it for a test that specified functional programming and not with some hard trick. But that means I'm using it everywhere. I love C#, but sometimes I write in a Python code and pretty other languages code because sometimes it's just better. Yeah. And
I mean, and there are languages like Prolog. If I'm doing logic programming, then I'll use Prolog rather than F# or C#. And if I'm doing database queries, I'm going to use SQL. And if I want to do a lot of meta programming, I'll probably use Lisp or something. It's just because some languages are better at certain things than other languages. And it's the knowing lots and lots of different languages and using the right tool for the job is really important. And I think the idea that one programming language can do everything, I think that's not good. I think people should learn lots of languages. It's fun, it's interesting.
But at one moment I found out that there is a web framework for R.
Yeah, you see, that's the wrong way of doing it. It's like, that's because people say, well, I know R and I need a website, so let me use R to do a website. And it's like, that's exactly what I'm talking about. Now, if R was compatible, if R was on the .NET platform or something, then you could write a web framework in C# and then you could use R at the same time, and exactly. But that's typical. Or same thing with COBOL, a web framework for COBOL or Fortran or something.
Machine learning on COBOL, why not?
Yeah. I mean, it's because people I mean, the funny thing is that learning a programming language is actually not the hardest thing. I mean, learning COBOL, I guess it would take you a couple of months really to learn.
If you have an idea, for example, learning F# is not hard if you can take an idea of functional programming.
Yeah.
But no, you can learn F# even without an idea of functional programming.
You have to be willing to change the way you think. If you come to learning F# or any kind of functional programming and you say, why can't I do a loop? Why can't I mutate things? Why I'm just used to doing it this way. I want to keep on doing it the same way. You're going to have a lot of problems because that's not how it works. The best way to learn a new thing is learn the way, the right way for that language. It's like learning a human foreign language. If I learn Russian or I learn Chinese and I say, why can't I do it this way? Because that's how I do it in English. It's like you're not going to get very far learning that language.
Yeah. Exactly. Also, that's the reason why when people asking me about what language you choose to learn functional programming, I usually take Haskell for it because you have to write in Haskell this way. There's no way to do it another way.
Way out. Exactly.
And in F# you always can make something mutable, make a loop, make anything.
There are backdoors. There's a lot of backdoors. Exactly. There are a lot of backdoors in F#. And so Haskell is definitely forces you not to do it. Yeah.
Actually, you notice a very important thing for our listeners is that, in other words, use an appropriate tool for an appropriate task, for an appropriate solution. If functional programming is suitable, okay, let's do it. If I don't know, all object-oriented programming with 9 levels of inheritance is suitable, kill yourself or something like that. And to be honest, when we are going to talk about industry, I would say we used to follow this approach during the last years, but then Go happened.
Yeah.
Go happened, and there are a lot of experienced programmers. I'm not talking about ex-PHP programmers. I'm talking about experienced programmers say, oh, great, let's go to Go.
Yeah.
And start writing code as our ancestors. Without trying to, without functional, without OOP, just to, Turbo Pascal. And and what do you think? I mean, maybe we don't need some functional things. Let's use Go and get rid of.
I like the idea of going back to. I think we've got. People make things too complicated, and Go is a good example of by deliberately you can't do complicated things and you're forced to do simple things, and therefore it's easy to understand. I think Go takes it too far. I would still have generics in Go, and various other things that Go doesn't have. But I like the idea. I think that that idea of having a language where you have to write it in a certain way. But I think Go is it's the trendy language right now. I will come back in 10 years and see how maintainable all these Go programs are, and see, because 10 years ago Ruby on Rails, 15 years ago Ruby on Rails was the trendy language, and now people are like, it's really hard to maintain old Ruby code. We will see. I'm just going to cross my, come back in 10 years and see how it is.
There's always a problem with SQL. When you doing a SQL of anything, you have to add more here. You have to add more features, more anything, and that works for anything, even for languages.
Yeah, exactly. I mean, people always look on when it's a new thing, they always focus on the good things about it, and you look at the old thing and you say the old thing is bad and the new thing is good, and then eventually you realize the new thing is maybe not as good as you think it is, and maybe the old thing actually has a couple of things about good things. Microservices is a good example. People are saying microservices. Actually, maybe you shouldn't use microservices for everything. Maybe modular monoliths are actually a really good idea in most and you don't have to do microservices all this.
Or maybe you should just use Brain. And think of a moment of what you're using, why you're using, and so on.
Exactly. Don't use it because it's trendy. Use it because it's a useful thing. Yeah.
Yeah, and actually we just discussed this problem. Because if you use Brain, if you use Brain, you have a lot of influence to your decisions.
Yes.
Influence from your experience, influence from trends, influence from this guy who say that serverless is good.
Right.
And it's so important to be clear-minded and get rid of these influences.
Yeah.
And what do you think? you can be considered as a great influencer in F#.
Right. Okay.
So should we get rid of your influence?
I actually think that when people follow somebody and some people have followed things that I've done on my website, just because I've written on my website, and I think that's a bad idea. Just because I wrote it, I wrote it a long time ago, and I've changed the way I do it. And I was learning when I wrote that blog post, and I probably wouldn't do it that way anymore. So don't follow me just because I did it that way once.
There's always this funny thing. There's plenty of people who are speaking about performance in our conference. It's like some low-level stuff, like you can optimize this for millisecond with this giant hack.
Right.
And it always happens like it's pretty good trendy people who speaking it here, and everyone respects them. So this person who heard the talk about some pretty low-level thing you should never use in case you're not in great urgent, came to work and started to use the thing without the great urgent, and that's a problem. So again,
I would never tell anyone just to blindly follow what anyone says. You need to think. And what can I say? So if anyone says that they have to do something because I said it, it's like, in fact, that happened the other day on Twitter. Apparently someone said something and they based it on something was on my blogs, on my website. And I said, no, that's wrong. I wouldn't do it that way. I may have said that 7 years ago but I was learning, and I was, I've changed my mind. So don't blindly follow influencers.
Yeah. Thank you. Actually, to be honest, we are running out of time.
Yep.
I had to take you to interview
for lifetime.
But we are running out of time. Thank you very much.
Thank you.
That was fun.
Great pleasure.
And profit.
Thank you very much.
Fun for me too. Thanks.
Very good. Thank you, everyone.